All right, in this stream, we're gonna look at this interesting tweet that was by John Rager, and he was asking, does there exist an operating system that can take a well-defined binary and enforce a deterministic timeout on its execution? For example, by killing it after it executes n user mode instructions. So this question, while it sounds maybe boring to a layman, is actually a really interesting question. This is basically saying, is there any way that you can get kind of a deterministic control of, one second here. One second. I was getting a message by a GM. Okay, never mind. So when you're executing things, having this ability to kind of deterministically stop execution or know where the execution was deterministically is really important for my research topic, which is fuzzing and kind of understanding like how programs work. So I actually, we'll read this thread in a bit, but I started a project and haven't done anything on it recently on my GitHub. And I think it's called Orange Slice. Yeah, Orange Slice. So the goal of Orange Slice is to make a fully deterministic hypervisor for Intel x86. And basically the goals there would be that I could somehow run an arbitrary guest inside of a VTX virtual machine hypervisor guest, whatever you want to call it, and have full determinism in it. That means that I could have a whole operating system running in there with interrupts and all sorts of things. Obviously, I have to emulate the hardware deterministically. But the goal would be that if I ever found a bug, if I'm fuzzing Windows, if I'm fuzzing a userland target, that I would be able to reproduce that bug. So I started this project called Orange Slice, which is a kind of a fork from some hypervisors I had laying around. But I did actually all of this dev so far on Twitch, way back when I was kind of just getting into doing these streams. But I kind of talk about some of the things that I would want in that world. I want everything to be deterministic. I want instructions to come in on the same interrupts to come in on the same instruction boundaries. And that is a really, really hard problem. It requires that you understand exactly how the target program you're looking at runs and having some way to stop it early such that you can deterministically do these context switches. Now, this question, when it came up on Twitter, is basically asking the exact same question that I need to solve in Orange Slice. And it's basically finding a way that I can deterministically, in this case, kill a userland application, but in my case, it's to cause like a VM exit or to break into a VM to deliver an interrupt on a specific instruction boundary. So we're going to read through this thread because I might have missed some messages, and we'll just see if there's anything in here that's going to be relevant to this stream, and see if we can answer any questions that came up in this thread on this stream. So, Travis Downs responded, viewing threads in Twitterland is impossible, isn't it? I'm gonna open this in Chromium, so I don't have the Zoom. I have the Zoom plugin for my other monitor. Okay. So, let's see. Someone responds, does timeout suit your needs? I don't know what timeout is, but I'm definitely not is the response. I'm guessing this, runs a command with a time limit. Sure, look at Solaris resource controls. Once again, another time limit suggestion. Using Intel pin, yes, that's totally doable. If you do like full instrumentation, you would be able to potentially go by number of blocks or number of functions or calls or so many different metrics that you could use. When pin is involved, you can make pretty much anything happen easily. Okay, even that wouldn't stop at a deterministic point. For a multi-threaded program unless you enforce determinism of threads. I want the OS to handle. Let's see where this thread goes. Actually, I think the best way to read Twitter is to go from the high level and then dive into the threads. It's Travis. I'm in a bar with no headphones, so people are looking at me weird. Oh, man. Hello, bar crowd. Round is on me. Super high overhead, but would ptrace with single step work for you? Yes, I've used tools like that, but it's too slow in this case, and I agree with that. Sounds like instruction tracing, something like pin dynamo. Yep. How is it going to handle interrupts? I'm guessing, okay, yep, we're just ignoring kernel mode in this case. We're going to see if we can solve the interrupt question as well here, because the interrupt question is a superset of the userland question, but we'll kind of restrict the problem set more and more as we run into issues. Interesting, sounds pseudo-deterministic. Single-threaded, so yep, single-threaded we can do with that. That's pretty easy. Job objects. That looks like a time thing as well. Unless you can give icount here, but I don't think you can. Yeah, time limit here, it's going to be in nanos, so that's going to be derived from the timestamp counter. Could do a dtrace where you, I think, yeah, single step. Instructions are not executed in order. Yep. Okay, so that's the one you want to expand. Yeah, that was my guess. QMU. Okay, and then I brought up you can potentially use performance counters to track instruction counts, and then you can break in and try to figure out where the instruction boundaries are. And that's basically what I plan to go down on this stream, unless something incredible came up. That would be more priority. So more perf counter things. Okay, someone recommended perf counters. And other than this, this is ticks, which are not deterministic. But I do agree with that to some extent. And what else? I see basically nothing else here. So someone brought up some of the techniques I'm using. It's not open source, yeah, sad day. Maybe I can do this research in Orange Slice for this stream. If I can do this research in Orange Slice, then I can actually make our findings public, and that might be useful to y'all if you're interested in playing around with these same things. Okay, so here we go, taking another shot. Okay, so we're gonna dive into that thread. It looks like everyone basically suggested single-stepping timeouts that weren't actually deterministic, or kind of this perf counter stuff, which we don't really understand how it works yet. So let's take a look. Where was that thread? This one, I think. Okay, we got some forks. I really need like a tree-based viewer for Twitter. I looked before for something like that, but I really wish I could give it the root tweet and it would like give the tree of replies, because this is a tree structure. Set OS, let's see what we got here in this thread. Blah, blah, blah. Okay, minimizing interrupts. We're going to see if we can solve that interrupt problem. Near the bottom, I had another suggestion about using Intel PT, which might be interesting. Yeah, you would be able to generate the trace and see the length of the trace. And the performance hit from that. So PT is kind of difficult. Can you guarantee that the application has the exact same like state every time it starts? Because if any branches change, then the disassembly changes, and then the graph changes, and then the PT trace means something different. And then also with PT, you kind of have to deal with that you would have like indirect jumps at different addresses, so you couldn't do a direct comparison, but you could maybe do like a fuzzy comparison or be like mod off aware. But yeah, I think there's probably a way that that's doable with PT. PT, I don't think would give you an ability to interrupt it at an arbitrary point. You could constrain the size of the ptrace buffer, and then I think you can get an interrupt on overflow of that buffer. That would be a really interesting thing to try, potentially. It's really hard to say. Anyways, okay, I guess it's probably this one with 39 replies. Here's one of Paul's recent tweets. You could work up from there. Okay, so we're going to go up the stack. Non-atomic reads shouldn't be an issue once the time process is stopped. So counting interrupts seems plausible, probably more so than trying to make Linux fully deterministic, even on one core. Yeah, so that's one thing that would be nice about performance counters is you could potentially, with perf counters, you can potentially, like, since you can filter based on different properties, I think you can filter on user supervisor. I know you can filter on user supervisor. I think you can filter versus guest and host. And you might be able to filter on CR3. I'm not quite sure. So let's see what we have here. We got a reference to this paper, or I think it's a slide deck. Could count hardware interrupts and subtract that. Let's see. Speculative execution, if you count UOP retired, UOP's retired, I'm pretty sure includes speculation. So you'd lose your determinism there. We can verify that. Let's see what else we got here. Have a perf event cause a sig stop at a limit and then single step for the remainder. Yeah, that's effectively what I think the best goal would be. The issue we are discussing is that interrupts could cause an erroneous +1 count on instructions. Oh, you think the IRET, like returning back? Where's the extraneous instruction? Would this be from? Let's see. That's all I really care about is where the concerns are of the non-determinism, because that's what we're going to test. We're going to go through and we're going to set up iCount perf counters, and then I'm going to try to figure that out and single step. Like single step through something and then use the perf counter and see if it's deterministic. So we're probably going to end up jitting something. We're probably going to jit like a known size instruction thing, and then we'll throw some interrupts at it. We'll throw some userland kernel transitions. We'll maybe throw some exceptions in there. We'll throw in some like move SS instructions, so that should like cause things to actually get thrown off by one. Bunch of things that we can kind of look into. Oh, yeah. Before we go into this, MetaConstruct has a really good question. Making assumptions about being on a particular platform here, or does that not matter ideally? Yeah, because if we can play within the undefined behavior of a specific microarchitecture, to be honest, basically everything is Skylake from the past 5 years, so it will probably be the same on any Intel processor from the past 5 years. But we could potentially be looking into undefined behavior in what we're about to do. I personally am comfortable going into undefined behavior, but I don't know how well that's going to answer the question at hand here from John. Anyways, let's get Sushi Roll up and booted. I haven't run Sushi Roll in a while. Let's make sure it still builds. It should, unless Rust has changed. Looks like that has gone stable. So let's modify this. Oh, nice. I have the assembler in here, too, which will be useful if I do some JIT. Slice patterns gone. All right. Oh, and we're using it there, too. Kernel, source main, slice patterns. One less feature of the many that is now stable in my OS. Pretty much every time I do a Rust Up update, I have to rebuild like my whole kernel. Cargo run clean. Cargo run. There we go. So let's see if everything builds here without warnings or errors. I just want to have like a clean starting point for what we're gonna do, and then I'm gonna need to spin up. I forget the Python Pixie thing. I really need to make note of it. Let me see if it's in my history. History. Grab Python. Yes, it is. Echo this to pypixie.sh. Okay. So I have this bin sh and then cd home pleb and this, and I should be able to chmod plus x pypixie. Okay, hopefully that is running, and then we'll open another stream to run the kernel. Actually, let me make sure before I open this kernel up that I don't have anything I shouldn't have in here. Main. Yeah. Comment that out, and we'll rebuild it. Carry on. Okay, should be good. Got the kernel there, we got the graphing here, and then another terminal to build. Carga run. And this should hopefully boot. I actually had a power outage recently, so I'll probably have to reboot this machine. Okay. I don't know why IPMI is always so slow. Here we go. Reset server. And we should be good. So that server will now boot up, and this will boot from our operating system here. So we'll have a clean environment. This isn't talking about Linux, but we're gonna figure out if it's physically possible on Intel, and then from there, it's just a matter of plumbing to get it to work on Linux. Paul has a POC of the interrupt half of things. Okay, let's check this out. Doop, doop, doop. Okay. I ran this in GDB a couple times, and the distribution seems to hit the exact same timing the majority of the time, with some skid that can be off by about 20 instructions. Okay. Wow, fancy. Perf event open, that's going to open a perf event, and here we're just going to create that perf event. Hardware instructions, and then this is just I guess this is just a volatile to get rid of the loop optimization, and that's going to loop, and it's going to stop on a specific boundary. Okay, cool. But it has no single stepping part. I see. So conceptually, we think that this is probably going to work then. So according to this, it's only been off by about 20 instructions. Let's go skid to stop updating the counter, but that one seems consistent. Huh. Yeah, this is really cool. I like this. I will go over to this one where I can like tweets. I'll give you a good like on that, and then let's get you followed as well. I think that will be a useful follow if we're getting GIS posts like that. Okay, let's make sure our kernel is running. Print kernel up. So I suspect that from that POC, then this is probably going to be all we need for determinism. Okay, kernel up. Good, we got 3 threads online. Nice. So let's go into source, CPU research, and what am I interested in here? I think, let's go into cache out. I think this will have, yeah, this thread ID stuff. So if the thread ID is not core, if it's equal to core 2, we'll go to core 2, and we're just going to pin everything to core 2. All the other cores are going to get halted, so we won't have to worry about those. And let's just make sure we only get one message printed here, which we should now, and that will get everything in a much cleaner state. There we go. Yep. Only one thread running. Everything else will be halted at this point, which is good. He breaks in GDB and checks the loop counter. Oh, I see. The 20 dimensions is a fixed skid. It was usually 20 off. Okay, let's do some histograms then. I should have perf counters right here. So let's see. We've got the instructions retired, which I'm guessing is what we're gonna end up using today. So let's get perf counters up and running. Let perf counters equal to perf counters new. In fact, we should move this into CPU research inst count perf counter determinism. And we'll make a new project here. Inst count perf counter determinism. And then we'll just call this main. Surprise SMM interrupts. I don't think SMM would cause issues there. I'm not quite sure. It's actually kind of hard to say if that would have an impact. So let's go into someone showing up on my screen. Oh, is this dude gonna attack me? He's just hanging out here. No, and he's walking by. Okay. Not sure about SMM. Don't they cause the same problem as regular interrupts? Yeah, I'm not sure. I would hope that interrupts would cause the count to not get counted because it's not tracking userland. But I'm not quite sure if that's going to be the case or not, so we can take a look at that. I think not, but also on the boxes I've seen, they're infrequent, like, SMMs are really rare. They're typically more like user interaction. They're like sleep events, scaling events, thermal events, or sometimes I think SMM originally was used to convert like USB herbs into PS2 herbs, such that you had like PS2 compat and operating systems while using a USB keyboard without having to change anything. I think those are like the common things that affect SMM, but I'm not entirely sure. So let's, we gotta make a file here. In fact, we're gonna ship this off here. And we're gonna take a look at, oh, sent the wrong one. There we go. So 5 is gonna have the building and running, and then this is going to have our codes. Oops. USB source, CPU research, and inst count perf counter determinism, mod.rs. And we'll do oops. We gotta, I guess I don't want to do that. I want to just make the file name source, SP source, CPU research, inst count. I can tell I'm tired because I'm making a lot of mistakes right now. All right, fn main. So we got main there, and we just have to pull that in as well in source CPU research mod, where we're gonna pull in inst count perf counter determinism. Hopefully that will build. Okay, cool. Looks like we should be good. And then this will just move up into this, and we'll kind of call it a day. It was usually off by a small amount, but usually the same, and then sometimes 10 or 20 more instructions. It's okay, we won't tell about the mistakes. Usually off the same off amount, exactly the same. That was really promising. Okay, yeah, that's kind of what I would suspect. Let's see if we can get perf counters in here. I don't remember where I'm using perf counters. I'm gonna pull up on another screen, another window, for myself to kind of look at this project, because I'll have things in here that I don't want to put on stream. Sushi rolls, kernel, source, and we'll go into there, and Let's see. I think I have some nice helpers. Oh, someone's trying to lure wasps on me. Oh, the standard shit, dude. Yep. 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 Yeah. Are you not Enigma? No. No. You just have to kill my shielding shit. Aw. Go lure me new wasps. A wasp lure on my makers. It's hard to carry them up. I can. I'll get this guy some wasps. God damn it. This is the downside of having to maintain a character. I'll get him new wasps. But they lured onto my makers. There are no wasps. Doop, doop. Yep, no wasps. They despawn. No wasps spawned. Sorry. Because when you pull them by, they lure on the rat and will kill it, and I lose. You owe me two. You owe me two monsters. You owe me two monsters. I mean, they were on my rat. Okay. Well, whatever. All right, we'll go back to this and we'll see. Doop, 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 doop. Wi-Fi is bad here. I'm next to the blender. It's drink blender night. All right. Oops. Attacking on the wrong character. There we go. Fixed. Okay. All right. Perf counters. Can't call that. It's private. Yup. So we gotta make that public, and we should be good. All right. This and perf counters. We gotta pull that in. Where do we have that? I think that's just use source or use perf counter performance counters. Why did I type that out? Performance counters. All right, here we go. So now I should be able to make the perf counters. Okay, we'll do that. Call into that function. And let me message this dude. Sorry, man. People try to lure wasps me all the time. It's just But yeah, I guess he was grabbing those just for training. Okay, performance counter's new. Yep, there's nothing for that. We call it a init instead, and we're back in business. And this is going to, I think, enumerate the performance counters on the system, and this is going to kind of tell me what's available. Let's see. Yep, perf counters, V4, 8 counters, 48 bits per counter, and then I should be able to go in and grab one of these. So I think I can query what I have. So I can do register resolve. So we'll do let retires is equal to perf counter dot resolve retire inst retired dot nep unwrap. I think we're good. So that'll retire on any processor. Counts when the last up of an instruction retires. Okay. So I think that one is accurate. So that will look that up, and that'll give us the counter, and then I think I have to program these. I forget what I did for my API here. Okay. Let's see. There you go. Oh, it's on the monk. Yeah, I see. I see. Yeah, this is a predicament. Fucking kidding me? One second. Helping this dude out. Alright. And there we go. Okay. Alright, so we've got that perf counter, and then here we have to resolve, and then read fix set. I forget how I program these. Probably not enable. It's probably enable. Performance counters enable. We're going to enable the ID retires, and we're going to enable it on perf counter 0. So this is an enable counting of retires on performance counter number 0. And I should be able to read that then. Loop print. We'll print out the counter, and I think I just do performance counter read 0, and then time sleep. Let's just sleep a bit so I don't end up spewing to the console, because the serial port will end up like breaking if I end up like, it's really stupid, but the the serial port over the IPMI will end up like crashing if I print too much, which makes no sense, but you know, that's just apparently how things work in IPMI land. So print the performance counters, and use time, use creates time, and that should hopefully pull that in. It's been a while since I've coded in my OS, and I typoed something, didn't I? Performance C counters, oh boy, we're struggling today. And retires, expected a... Really? Ah, it's the other way around. I think that makes more sense anyways. Past me wrote better, I guess. And then, yeah, we can't reach that. So this is printing the instructions retired. That looks pretty accurate. My sleep is a hot sleep. So we should have like a lot of instructions being executed. Surprisingly, not as many as I expected. That's only 1 billion? That's actually a lot smaller of a number than I expected. Really? Really? We got... How's that only 1 billion? Why is that number so low? I guess maybe my... Huh. Well, anyways, we're gonna do, we'll try and get something a little bit better here for an example. So I'm gonna enable that counter. That's gonna have a write MSR, and then I just wanna disable it right away. I'm gonna see. Okay, so that should disable that, and that will disable it by writing it, and then that clears the perf counter. Well, I don't want that. I'm gonna just have, disable not clear it. Disable no clear. Call that. Disable perf counter. I don't know if there's something that I previously wrote that relied on that behavior. So this is going to enable it. That will zero it out. So the way this works is this is going to, on the enable side of things, we're going to clear the count for that perf counter, and then we're going to enable it with a single write MSR. and then this will clear it. So the code that's going to be emit here is probably write MSR, and then a load EDX and EAX, and then a write MSR again. So we might have to end up looking at the assembly to see what we actually generate here. But I suspect this is going to be like 3 or 4 for this count. 4. Okay. And that looks really good. So let's assert. We're going to do this in a loop quick. Just to see. Just to start off. Oops. Tabs are getting really screwed up here. We're going to do this in a loop, and we'll enable that, we'll disable that, and then I'm going to assert that this is equal to 4. So that should be pretty stressful of that. That's basically going to look for any situation where that is not equal to 4, and I expect it's basically going to be never. Yeah, so we're never seeing that value be different, which is a good sign for the instruction count stuff, and it also means that my OS is very quiet. That's the biggest thing I'm trying to test here, is I'm trying to figure out if my OS is quiet or not. So here I'm going to do like let me latched is equal to 0u64, or actually this is going to be equal to none. So we're going to track the first count value and check for determinism. Actually, I'm just going to do this. We're going to do observed counts, and this is going to be a histogram. Map new, btree map new. This is going to be a map from the instruction count to the frequency that count has been observed. And then here we'll do use collections. Nope. This is in alloc collections btree map, and then here we'll do count is equal to performance counters read, and then we'll do observed counts dot entry count dref plus equals 1, and then for ii in 0u64 dot dot if ii and ox is 0, print this database out. All right. Entry cannot be dereferenced. Oh, or insert 0. Deref that. Did I really get rid of that deref? I'm kind of surprised there. I'm not using time anymore. That's fine. Okay. All right. Doop. 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 Okay, so we're only seeing the 4 get observed. That's good. So now we have like a rough baseline here, but we're not doing the interrupt thing yet because we're just kind of going to play around with these perf counters in isolation to see how deterministic they are. So we know that 4 is the baseline. So just the instrumentation itself is 4 instructions. So I'm going to make note of that. My notepad here, I'm going to say perf start plus stop equals 4 inst. And we're only ever seeing 4. That is a really healthy sign. So one thing that I can look at is yeah, I can kind of look at if the, let's see, I actually kind of want to look at that assembly. What's a good way to do this? I'll put some nops in here. I actually think when I build the kernel, I think I have something that disassembles it, and it looks for some specific sequence. Yeah, here it does. So we're going to have it look for, like, I guess I want to kind of name this. Yeah, stream think I want to change this. I don't remember what this code is, but let's put this as like astif. That should be good. And then this will be end. Okay, so astif and end, and we're gonna get those directly into the code. So let's see if I can do that here. So we'll add assembly here, and we'll do just do a multi-line jump, one forwards. Then here we'll write in astif. I don't know how to do that. Hopefully this works. I don't know what the directive is for this assembler. This is just like gas assembly, I guess. And then we have one here, and that quote, and this is Intel volatile. We'll mark it as a memory clobber, so we don't have memory getting moved around. And then let's just see if this builds. No way. Use of inline assembly is unsafe. Yep. I might actually put this in a function in my like CPU research helpers, because this will be an interesting thing to have, like a start marker, end marker, unsupported relocation type. Ooh, let's see. Gas assembler define string. Yeah, I want to define a string like in place. ASCII? Okay. Really? Nice. And then couldn't find the PMC sequence because it couldn't find the end. So here we'll do, this is after we stop the counter, so it doesn't matter. And then here this will do end. And then hopefully this will show a disassembly of what is in here. And we do have that. I'm going to want it to cut forward past that, so we're going to modify this a little bit. Oh boy, been a while since I've pulled the Intel SDM from underneath the FED. Oh, it's such a good thing to have, though. Needle position plus needle.len. That'll slice that down. And then end sequence plus the end sequence.length. We don't want to include that there. And now this should magically, okay, maybe not. Really? Needle.len. Oh, that's the end position. .windows end sequence. Ah, here we go. Needle.len here. This one I shouldn't need. Not that it matters. It's the same effect. Okay, so now this is the code under test between those two blocks. And that should line up with what we are emitting. We have a jump here that we can just ignore because it doesn't matter. Actually, I can just throw that in here as EB06. Because that's always going to be the same length on that. Okay, so this is everything between these two markers. So now we have a way of like seeing what code is being generated between these two markers, because this is going to be nice to kind of figure that out. Thank you for this for the sub, Yudoko. Thank you so much. Let me actually get some music on here. It's kind of weird when I'm like just talking to myself without music, which is strange. But there we go. And now I got music. Okay. And you guys shouldn't be able to hear the music. Yeah. I don't want this to get copyright strike, because that hurts kind of who can actually view the video. Anyways, so this is going to clear the perf counter 0. This is the one that's enabling it, and this is what we're seeing. We're seeing a retirement on write MSR that's enabling it, because the perf counter gets enabled in hardware prior to this retiring. And then we see 1, 2, 3, 4 instructions. We don't see this write MSR because similar to this one, this write MSR is not observed because the perf counter is disabled in hardware prior to this instruction retiring, if that makes sense. So these are the 4 instructions that we should be counting with our perf counter thing. All right. So with that, we should be able to now kind of do random things and researchy things here. I might actually kind of want to cut this down so I don't have to see it. I'm just concerned that I'm going to miss where this is. I don't want to put the jump in here, but I kind of want to trim this out so I don't have any of this stuff at the top. I could potentially hard code those. We'll deal with it. It should be good enough for now. So now in here I can do I'm just gonna mark this whole fucking loop unsafe so we don't have to deal with unsafe things. We're definitely gonna have some unsafe in this loop, so this will just simplify things. So this is gonna be the assembly start, assembly start marker, assembly end marker. Okay, and what do I want to look at this over here and see if that's okay. Okay, so I think we should be able to just do this. Unsafe, get rid of this one. Assembly end marker. Would you mind quickly explaining the project? Sure. So what we're looking at here, this is actually a custom kernel that I've developed. It's just an x86 Intel operating system that's meant for learning how the processor works. So it's super high levels of introspection, and it's basically so that I can analyze and research how the Intel processors work. And I typically use this to understand the undefined behavior in the CPU. So in this case, this stream is actually forked from this tweet. So John tweeted about whether or not there's a way that you can deterministically stop an application after a certain number of instructions, or in some way deterministically stop an application. And it's actually a relatively hard problem. So one theory is that we can use the performance counters in the Intel processors that count the number of instructions that were executed. And if we count the number of instructions that were executed, we can potentially stop the VMs using an interrupt in kind of a weird overflowy way to cause an interrupt to come in on that, hopefully on that instruction boundary, which then we could single step the remainder of the instructions. So we're trying to figure out, first of all, can we actually build upon the instructions retired counter? Is it deterministic? Is it reliable enough for us to build on? Because if it's not, then we can't go down this path at all. So I just set up a framework now that allows me to kind of look at that counter over many, many cases, and it's going to print the different values we saw over the counter and the frequencies. So this is kind of a histogram, and this is saying that every single time we've run this code snippet, which has these 4 instructions, we see that 4 instructions executed, which is exactly what we wanted to see. So now we're going to add some things in here to see if we can kind of change this up. So we're going to go and add this, and I'll do a move RCX. We'll make a RCX clobber here. Move RCX 1000. I'll make a label here. Deck RCX jump non-zero 1 back. So this should cause 1 instruction more, plus these 2 instructions will get executed 1,000 times. So 2,000 plus 1, 2001 plus 4, 2005 is hopefully what we're going to see here. Maybe I did the math wrong there. I think that is right. 1, 2001. Yeah. So hopefully we see that. Jump non-zero. 1 back. I think I need to do that. But I didn't mark that as a clobber. Yeah, you can't use 1 as a label, and I'm not sure why. I don't know what 1 is. You're gonna execute that ASCII string? I jump over it. I jump over the ASCII strings. Jump 1F. Jump 1F. We'll make it 2, though. But we do jump over the ASCII strings. Okay. So, we can run this, and, oh, am I going to? Oh, because I copied that on accident. That was my mistake. That one. Yes, I agree. Okay. So now we can see the example code and what was generated. And there we go, 2005, every single time. I probably need to, let's change this to be smarter. Let mute next print is equal to our time future. We'll print every half second. And here, if time RDTSC is greater than or equal to next print, then we'll print next print is equal to time future 500,000. Okay, so now we'll print every half second, so we don't have to worry about how that's going to be handled. We're not using II anymore. It's fine. We'll just do underscore. Okay. And we should be able to see the code, and it should be 2005 again, but we'll get more prints here. And there we go. So there we can see 2005 instructions every single time we run it, which is cool. That's exactly what we want to see. Awesome. I'm pretty happy with that. Let's let me turn down my music a bit. There we go. All right. So that's executing 2005 instructions every single time, which is exactly what I expected. That was like the goal. That's what I wanted. And I'm really happy with that. So now we can try and see if we can cause that to get kind of messed up. So we want to look into source perf counter. And so you got the perf counter library here. What can I do here? Perf event. I see. Perf event has the bits. That will track the different ring levels. And let's see how I do that. Supported perf events. Insert. Register. Okay, so if I set this to not track in OS or user, it should just hopefully stay 0 forever. That's what I would expect. Yep. It's just 0, and then if I have this track just kernel, because we're only in kernel space right now, and we'll just track this. Okay. That looks great. And now, what I can do is, let's go make an interrupt handler. I think I use NMI for this. I think I already have this built in. I have freeze on overflow implemented. So we're gonna do this. Performance counters freeze on overflow. So that's going to configure the performance counters to freeze if an overflow occurs. So this is enable freezing of the performance counters on an overflow. Okay, and then here we'll do enable set enable. So instead of 0, we'll fill in a value of 1 shift 48 minus 1. Should be 1 instruction. We'll actually go 1,000 instructions in. So 1 shift to the left by 48 is the maximum value that can be held in a perf counter. That comes from perf counter bits 48. So 1 shift 48, then we subtract 1,000 from that, so it will overflow in 1,000 instructions. Now I think, let's see, performance counters. What did I do? I typoed here. Performance. Nope. Performance counters. Where did I typo? Oh. Performance. Perf. There we go. It's Rust. Yeah. So, are you coding this in Python? No. This OS is written in Rust. I'm just using a Python script to interact with the server. Okay, so we're always seeing 1,005. That is beautiful. That is amazing. Really? Really? So I set enable that. That will then cause them to freeze, and then enable. So what does this do? On freeze, enable freeze on PMI. On PMC v4 and later, are we v4 and later? I think we are. Yes. On v4 and later, this sets the perf global status counter freeze to disable counters of an interrupt. This does not change the perf global MSR. Okay. So that will end up freezing that. Set enable. That sets the value, and then sets the perf counter bits there. So that matches what you're seeing on Linux. Okay, good. So, what is that? What does it mean? How is that? I'm confused as to disable. It says 186. Enable sets 186. I'm curious as to how it's getting unfrozen. I think it's only running once. I think it's only running once. Can't move RD-rand. RD-rand, RCX, and RCX OXFF. So I think we are only seeing the first value because I'm not resetting the perf counter subsystem. I just need to make sure. This is just a test to make sure that I'm not screwing something up. What happened here? Oh, I can and with 0 and infinitely loop add RCX1. Okay. Here we go. Okay, so we are seeing different counts. So the 1005 is the overshoot. Yeah, that means I'm hitting it perfectly. Huh. I don't know how I'm re-enabling that. On that freeze. Disable all via perf global. Enable counters. Based on this, it allows us to start multiple at once. Yep. Well, whatever, it seems to be working. I don't understand how I'm clearing the freeze bit. Freeze on overflow. Okay, and then let's configure this to NMI. So we'll do perf counters. We'll set freeze on overflow, and we'll set configure PMI to NMI. So that's going to cause performance monitor interrupts to cause non-maskable interrupt. Fault FN interrupt handler. So in this case, we have an interrupt handler. NMI used for performance counter, overflow coverage, drop it, EOI the APIC. Okay. Cool. So that should work. But for the original problem, maybe that's fine because it's presuming it's always the same program. Yeah, I think so. But yeah, I mean, that's looking really good. I'm not seeing any jitter on that at all. But now we have interrupts enabled. I'm curious if that's going to change anything here. We're going to switch back to move RCX 1000. So this should always be 2005, but we're going to interrupt at 1000. And yeah, so then the 1005 is the remainder. Let's see if I can do -1. So I think the right MSR instruction that enables the perf counter, I'm curious if I can cause, I mean, I need it to overflow. So this, in theory, this should be causing, yeah, we're like stopping specifically on any boundary we want, which seems pretty awesome, to be honest. So let's take a look at RCX. Can I get RCX from here? Interrupt handler frame SS. Yeah, save all the registers. Why don't I have access to all the registers? Well, interrupt handler, we're gonna pass in. That's enter rust. Here we're gonna pass in RSP plus 18 into R8, which is going to be, oh, and then we align the stack. 16-byte align the stack. If it has an error code, we 16-byte align the stack. Otherwise, we jump into enter rust. I just need to figure out where on the stack I can get access to the register state, because I actually want to see what RCX looks like, because that will tell me how many instructions were truly executed. Because I don't know, so far it looks really deterministic. I haven't seen any overshoot. RSP plus 18, RSP plus 20. No, it should be RSP plus 18. Oh, yeah, that's the, I see, that's the error code. And then RDX points to the IRET frame, which is the second argument, which is frame, interrupt frame. Okay, and what do I use in there? So then I have this. I might want to pass that in as an argument as well, actually. Push RCX, RDX, R8, because we end up clobbering all of those. Honestly, I can just use those. RSP minus 18. That's going to clobber those three. So, you know, what's up? How's it going, man? How you doing? It's going pretty well. I'm a little bit tired. Making a lot of mistakes. I'm going a little bit slow because I'm a little bit tired, but whatever. So I'm trying to figure out how I implemented this interrupt. We come in directly here. RCX, RDX, R8. Those are going to be right on the stack. And then we're going to sub 8 if and only if. Honestly, I can just take the RDX value and subtract off 1, 2, 3. 3 times 8. I'm just going to do I'm going to push R9 as well. We'll pop R9. Be in a rope. I wonder if the deviations you saw were due to interrupts. Yeah. So what I'm going to try to do is I'm going to like jit out a relatively complex application with all kinds of branches and memory accesses and things that keeps increasing a counter in some register, and then we'll hopefully be able to use that to determine if we have some sort of like deterministic break-in. So I'll break in, and then in the interrupt, I will check what the code count is and see what the performance counter is and see if it lines up correctly. Curious if you use something slow like idiv as the payload, if it changes. Yeah, so we're gonna end up jitting out like a complex application is my goal. That will have mispredicts and a bunch of expensive microcode things and just a bunch of crazy stuff here. So we're gonna I'm gonna move into R9 RSP. That's gonna add an extra argument, which is just gonna be the current stack. And we don't set the stack there, so that will be R9, R8, RDX, RCX. So I'm going to split this just so I can see a little bit better, and we'll go up to the interrupt handler, and then here we'll take a some regs, and this will be some regs, and struct some regs. That's always going to be aligned, so we'll be able to, we have to recurse this structure. Let's make sure interrupt. Let's make sure I have that. Okay, C and packed, which is good. Some regs, I can honestly make this packed because I'm not going to be using references into it. And then this will be R9, U64, R8, U64, RDX, and RCX. And these are all from... Yeah, these are all the original values when we were executing and the interrupt came through. So we'll have the like, literally right where the interrupt comes through, we're going to save these 4 things off. And then we'll LEA RSP, they'll be in R9, R8, RDX, RCX in that order. And then we'll derive debug. And then here, I'm just going to panic with these flags, with these registers. I just want to see what they look like. Wonder how rep moves stows interacts with that. Oh yeah, so oh, I need to make that public. Moves and stows, I think, are each an instruction. I think they each show up as an instruction retirement. Can't derive on packed safely. That's fine. We technically don't need to pack this. Okay, so this will panic, and we're going to see we have the retirement count set to 1. Are we not hitting the NMI? Huh. Oh boy. I wonder if I have NMIs masked. I shouldn't because I reset the processor. I don't think NMIs are masked. That's interesting. Configure PMI to NMI. Oh, I apparently disabled that functionality for some reason. I have no idea why. I don't know why I didn't comment out the call to that function. Past me was doing some weird hacky stuff. So we should see an NMI now. Oh my god, are you kidding me? Unless it's not doing an NMI. What is this? Freeze on overflow, resolve. Why am I not seeing an NMI here? Oh, do I need to set interrupt? I think I need to set interrupt on the pin. Freeze on overflow. Disable counters on interrupt. It looks like it still does even... That's interesting, so it still freezes it. Wait, it's not freezing it. I'm really confused as to what's going on right now. So... Interrupt. True. This should now cause an interrupt. I don't know how that's getting frozen then. I guess it's over counting. Okay, now we have an interrupt. Woo! Yeah, we panic inside of an interrupt. Apparently, panicking in an interrupt is not something that I support. Hopefully I didn't brick the machine. Nope, I didn't. So we should be fine. We still have reboot. Oh, does it work now? Aha! So it is frozen now. Okay, perfect. That's what I was hoping for. Much better. Okay, now things are behaving like I expect. So we'll do... clear the counter overflow bits. So I think every time I'm going to want to do a performance counters reset. And then I might have to re-enable them, I'm not sure. There we go. We got an interrupt, good. And let's see, another interrupt, good, okay. So let's, I wonder why I can't panic in here. Print, CPU halt. We'll see if this works. Uh-huh. Exception 13 on core 2. And I think that's due to the print. Unless I completely broke my interrupt handler. Maybe I broke my interrupt handler when I added the RDX crap. Let's see. Nope. So it is the print. I can't print in my interrupt handler. Why is that? Well, I'm just going to save these off into a global then. So we'll do pub static last interrupt regs. I guess, yeah. Last interrupt regs. This is going to be a sum regs. We'll mark, we'll implement clone and copy on here. Set this equal and default. Sum regs R9 0. I'm gonna have to zero them out. R8 0, RDX 0, RCX 0. And then we'll latch those in there. And the interrupt handler will do pub static mute. Deref last interrupt, whoops, last interrupt let regs is equal to sum regs. I guess I don't need to deref it, and then get rid of the print, get rid of the halt, and I think we should be good. I guess it does want all caps for that. Anyways, so that's running now, and we have a counter of 0. Which is what I would expect, because that is now disabling the counter. This lines up with what I was expecting before. So I didn't have interrupt enabled, and thus the counter wasn't getting disabled, so we were actually seeing that 1005 was from it actually overflowing and continuing. Now we're seeing 0, and 0 means no overshoot, in theory. So I should be able to now, let's convert this to uppercase. Last interrupt regs, and we'll see if we can squeeze this in here. Last interrupt regs, and then down in our actual code here at the end, We can do whatever we want because we're just reading stuff. I'm just going to print, along with that structure, I'm going to hex print the interrupts this and create. And that's technically a thread local in my OS by putting it in a global, so I don't have to worry about other cores, but all the other cores are halted anyways. Oh, perfect. Look at that. So RCX is it perfect? RCX, I'm seeing 3E6, and it should be, so this is our code under test. Here's our loop, 3E8. Oh, I think we missed. Because RCX cannot be 3E6. It could be 186. I would expect 186, right? When I put an overflow on one instruction, I would expect to see this would be the instruction that's writing it out or enabling the counter. An overflow would happen on the retirement of that, and thus I would expect to see 186 still in ECX. But I'm not seeing that. I'm seeing, what, 400? What about some of these other registers? RDX. RDX is EDI, and EDI is probably zeroed out, I'm guessing. Hard to say. Right MSR, yeah. Yeah, I think that's 0. Is it? I'm not sure. EDX, ESI, EDX, EAX, which we're not saving. I could save more of the registers so we could see the full register state. Enter Rust. So once I hit enter Rust, I then save off all the registers, but some of these I have to use the old version. So that's kind of what I'm avoiding. Like I can make it work, but I've got two different frames that I'm saving things off, so I'd have to like merge the two frames together to get the correct result. And that's something that I could do. You know what? We're gonna do it because that's something I'll probably want to have in my kernel anyways. So we'll actually move here. I'm gonna do a move of R9 RSP, then down here where I save restore R9, 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 R9. We know that it's always RSP plus 18. We know it's always that minus 18. So we have that information. This I'll save off where the stack is, and then that will give me all the XMMs and everything. So now I can do all regs, and we'll do XMMs, U 128 times 16. These are in reverse order. I'm not planning to look through the XMMs right now, so I'm not too worried about it. And then here we'll do R15, U64, R14, U64, R13. 10, oops, 12, 11, 10, 9, 8, BP, SI, DI, SI, RBP, RDI, RSI, 1, 2, 3, 4, RDX, RCX, RBX, RAX, R15, R14, R13, 12, 11, 10, 9, 8, BP, DI, SI, RDX, RCX, RBX, RAX. Okay. So XMM's there. Now, this is going to be all regs. And that's technically, we'll make that not mutable. So we'll call this regs. And this will be all regs. And I'm going to have to initialize that, which is going to be annoying. Because I can't do default. Because default isn't constant. which is kind of annoying, equals... I don't think you can do zeroed in a global. I don't think that's a constant. And I can't use standard. It'd be actually really nice if I could do that. If I could just zero initialize that global. Looks like I can. This is all regs, and then this is all regs. And this is going to be incorrect. Oops. It's going to be incorrect for those two. 122. All regs not found in the scope. Regs. Yes, we can't do that. Yep. All regs. This. Yoink. Paste. Delete. Delete. Replace U 0 through 9 plus with a 0. Okay. All right, so that's now going to build. So now that will save off all of these registers, but there are a couple that we will modify in here, RCX, RDX, and R8, which I need to get from earlier in the frame. So off of interrupt frame, I'm going to do, let's regs dot, this technically doesn't matter if I do this. Regs.rcx is equal to we can do struct repr frame regs. You know what? I'm just gonna update frame, interrupt frame. I'm pretty sure I can just update this. Where are these gonna go? Here. All right. RDX and RCX. And then here, instead of RSP plus 20, oh, because sometimes that's gonna have the error thing. Oh, that's so frustrating. Yeah, there's an extra value in there sometimes. Oh. That is annoying. Repr C, I think we're just gonna do this then. I think I'll need to track. Oh, what do I want to do here? I've got that interrupt frame coming in. Problem is I can't know the address of it. LEA, RSP plus 20 and RSP plus 18, they differ. Oh, but it's always minus 18 off of that. So we're fine here. Okay. RCX, U64. RDX, U64. All right, U64. These are registers that are saved in the interrupt handler OX18 byte right before the frame. I guess the frame has been fixed up because it's always 18. LEA plus 20. Yeah, I need to get the original RSP, and I don't have that information. I can compute it based on if there's an error code, because I could have another table. There are a bunch of different ways I could do this. I'm trying to figure out in my head right now what would be the way that I want to maintain the most. It's tough. I either need to set another register that will contain here's what I'm gonna do. I'm gonna push R15. I'm gonna move R15 RSP minus here, we'll just do move R15 RSP. Save off our special frame registers. And then this will just have to pop R15 in that order. Yep. So now we have an R15 in here as well. So R8, RDX, RCX, R15, U64. But then I can actually fix this up in enter rust, where we save off the rest of things. So in enter rust, I'm gonna go in here and yeah, so R15 will point to this structure, right? R15 points to R8. It points to that structure. So that points to that structure, which then means push R8 here. I can actually do a quadword pointer of RSP plus, or R15 plus 0. Quadword pointer R15 plus 8. I think this will work. Wait. As R8. Replace R8 with R15 plus OXOO. And then RDX. Quadword pointer OXR15 plus OXO8. RCX. Quadword pointer R15 plus OX10. And then R15. Quadword pointer R15 plus OX18. I think on x86 you can do a push deref, which is a really weird format, but we can do that. And we don't need a semi there. Oh, we do. What's it complaining about? Here, get rid of that. Okay, now we gotta fix up the other side. And we do the same thing on the return path. Pop R15. We're gonna pop quadword pointer R15 plus OX18. Then we'll pop for RCX. Quadword pointer R15 plus OX10. Quadword pointer R15 plus OX08. And what was the last one? R8. Quadword pointer R15 plus OXOO. So we're going to save those off. We save that into R15. We're going to pop everything from there. And then here we're actually going to save and restore from and to that stack. We're playing a risky game here. I could have completely screwed up my interrupt handlers. That looks accurate. Let's let that print out fully. Okay. Looks like a good frame. We've got racks. Ooh. That doesn't look too hot. That racks doesn't look right. Racks. RBX. RCX. That's the 3E6. Our DX is 0. Okay, good. RSI. RDI. RBP. R8. R9. Okay. I don't know. I feel like I did this right. Sorry. Okay. So I just have to double check this, because if I got this wrong, I'm gonna ruin this kernel, and I'm not gonna know what I changed. So, push R15, RCX, RDX, R8, we clobber R15, that's fine because we restore it here, we pop in the inverse order, and then in this function when we go into it, we're saving off R8, RDX, so R8 should be at 0, RDX should be at 8, RCX should be at 10, and R15 should be at 18. So we're going to deref those to grab the values that we saved here into this frame, and then here we're going to pop them off. Technically, we could do this without the memory accesses because we could actually like derive where these things are from, but this is actually relatively clean. Once again, 18, 10 for CX, 8 for that, and then, okay, I'm pretty sure this is now correct. I actually don't know how Rax is getting set. I would expect it to be 186. Oh, that's gonna push. No, that's gonna push the value that it derefs from here. And Rax should be accurate. I'm confused as to where that Rax is coming from. To be honest, I don't know. I would expect Rax should be EDI. Oh, is it? It is. Oh, that's the perf counter number. Okay. No, this does work. Cool. So now we can see the register state exactly at the interrupt site. So I think we're done with interrupts now. So we can close those files. So now we have the interrupt frame being saved into a global, so we can see what the register state was literally when that interrupt got entered. And from that information, we can tell that we see 3E6 in RCX, and RCX should actually still be 186 if it actually broke in at that point. And we see it's 3E6, which is really close to this, which means that we ran 2 decrements. So we're actually kind of off on our counter. So let me get rid of the freeze. I'm not gonna freeze them on an overflow. And what does that do? That's 1D9. 1D9. And we gotta make another one of these. We gotta make this don't freeze on overflow. And we'll end with the inverse of that. So we'll clear that bit. So this will disable on versions that. It's okay. So we disable that, and we're gonna say don't freeze on overflow. And then hopefully the perf counter will tell us the skew. So the 3E6 will tell us the count, and then here we go. So we see 2004, 2312. Ooh. Okay, we're seeing differences. 2004. Interesting. 2004, I think this is with the interrupt handler running. So I do want to freeze it on overflow. I'm pretty sure. But then I don't have the count. Because it literally stops counting at 0. If we do freeze on overflow, then the interrupt will come in, and the counter will be 0. Now, that's still deterministic, which is good enough for me. The question is the skew always the same? So we're going to see. Let's add some more decks in here. We're going to do this. Repeat 10 times, end R. So now we're going to have a better idea of where we actually stopped execution. Let's take a look at this. That's our code now. And here we go. So we have a freeze on overflow. And we overflowed. We had an interrupt going in. This counter is always 0, which means that it's freezing directly on the overflow, which is what I would expect. The question is, does this RCX value change? So here we see it is 3E4, and that means that this executed, so that's 1. I'm going to make tallies. 1 instruction executed, 2 instruction. This is now, when this executes, when this retires, it's at 7, 6, 5, 4. So 1, 2, 3, 4, 5, 6 instructions have retired. Yeah. And that's just the 2 for this, and then the 4 difference in this. Confirm that rep Stosby counts as 1 instruction? Really? Huh. I'm curious if that I think is different if there is an interrupt. Mod interrupts, yeah. Interrupts should cause a +1, yeah. So I'm hoping that with this freeze, it doesn't do that. So I'm going to assert. So this is 3E4, right? So that executed 6 instructions. So this means we overshot by 5 instructions. We had 5 instruction overshoot. And I'm actually just going to repeat 100, or I'll repeat 20 here, and I'm going to get rid of, I'm going to do XOR rax, or RCX. This is just going to be an inc RCX. We're not going to have a loop. We're just going to really simplify this. We're going to XOR, and then we're going to increment, and then this is going to be the number. This is going to be the number of inks that executed, and then we have the 2 overhead, so this should be 5. 5 in RCX, 6, 7. Is that what we counted before? Oh, is it? 5. So let's see if I change this to -2. Let's see if RCX turns to 6. And it does. I think. Wait. Whoa. 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 That stopped here. After the... Because RCX is 186. Dude, that is bizarre. RCX. Interrupt RCX was this. What? RCX is private. Yeah, we gotta make those all public. Source interrupts. Dude, that is bizarre. V S R replace with pub space RG. Dude, that is really strange. RCX 186. So we're going to make an RCX table. Dude. No way. Then that's stopping early. What? What? Observed RCX. No way. Times observed RCX dot entry Let's do let int regs is equal to this. Just ref it. And actually, we can make a copy. Why not? Doesn't matter. Get a copy of the registers from the last interrupt. Dude, that is crazy. Entry int regs.rcx or insert 0 plus equals 1. So we can say for count for insters, or for PMC val frequency in observed counts print PMC 0 histogram. Okay, and then we'll do 10, we'll do 20, and then 15 PMC val and the frequency 1 2 3 4 y3 paste. This is RCX histogram. Here we'll do pound 018x. This will be observed RCX frequency in that, and now we should have a little bit cleaner output. PMC val in 64, yeah, RCX. Having on the background to see your reactions is so good. I'm glad. I don't know, like computers just are mind-boggling to me. Let's see what we got here. Yeah. All right, we're gonna add some new lines. We'll do PMC histogram colon. Put a colon on this one. And then here we'll do a print, new line, bunch of equals, new line. Actually, I think I want to do that already is new lined. Let's do double new lines. Dude, that is bizarre. Yeah. That means we're interrupting right after this. And that's actually interrupting before the retirement of that instruction? Are you kidding me? My mind is being blown right now. Dude, how is that a thing? Let me do, let's see if I can get rip in here. I need rip. I need rip in my life. I do have rip from those frames. We'll do regs. Pub rip. U64. That's after R15. R15. Trying to figure out if I want to actually just store it in a different global. Store the frame. I'm really confused. I feel like I'm causing an overflow prior to the retirement, which I truly have no idea how that's possible. I'm just gonna throw in. We're gonna put in the. What is this? Interrupt frame. Pub. Pub. Now down here, I can do all regs. Fuck it. Last interrupt frame. It's going to be equal to interrupt frame equals interrupt frame rip 0 cs 0 rsp 0 ss 0 r flags, something like that. Let's ballpark what I want. Last interrupt frame. We're only gonna set these up on NMIs. Frame. Okay. 107, yeah. Okay. Ooh, that doesn't have the copy trait. Drive, clone, copy, debug. Oh, it's not gonna like debug on that because it's packed, I think. We'll just say clone and copy for now. Or because it, yeah. I've also started going back and watching your VODs at work, which is a bad idea because I don't focus at work. Focusing's overrated. Okay, so now I have access to the frame. Last interrupt frame. Let int frame is equal to create interrupts this. This will give me access to rip. So I'm just gonna throw int frame.rip. I think I can just do that. Or insert 0. Okay. Yep, and this is actually gonna be rip RCX, and I'll print pound 018x rip. It's gonna tell me the register state of rip, and we're gonna see if rip ever differs. Who knows? Sweet. So rip is now part of that. And what's this? 38E. This label here. ASDF, ASDF. I'm gonna global let's do foobar, global foobar. Please, 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 please let me assemble that. Please let me assemble that. You son of a bitch. Global. Yes. 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 Let extern. We're gonna call this marker end. Marker end. Marker end. It's gonna be doesn't matter. Extern marker end U64, right? I can do that. I'm gonna need to say extern static. Yeah. Static marker end. I think a semi here. Okay. So marker end there. And it should fail to pull that in, I think. When we go use this, we'll do rip offset is equal to int frame.rip minus as usize minus the reference of marker end as usize. We're doing some weird shit here. Not fun in the scope, of course. So hopefully this should fail to resolve that symbol. Can't cast that as usize. Yeah, so we're gonna do this, as const u64 as usize. So we're going to cast the reference into that, and then this should fill, hopefully, the link. What? I have no idea what this found then. Extern. What? What? I mean, I can do this. Let mute marker end usize is equal to 0. Or let marker end is equal, it's just a usize. And then here we'll have an output. And then LEA into 0. Rip plus 2F. So output into marker end, which we're doing, and we're LEAing rip plus 2F into that. So we're getting the address of that, and then we have here, we can get rid of some of this, and this is just minus marker end. And I think that's already a usize. I'll do the trick, I think. Rip offset, now we just gotta use that. I could have got the extern one working in some way or another, but this one's a little easier. Okay, so now... Really? Rip minus marker end? What is marker end? What? What? I'm just gonna print hex marker end. Should be getting the address into that. Is that not RIP? No, I think that is. What is going on? Where is... I don't know where. As rel... riprel... Yeah, that should be the address here. I'm trying to figure out if RIP is wrong, so we can print the address of this function as a pointer. See what we got there. Pointer not implemented for that. I don't think as pointer is implemented on a function. Nope. Can I ref main? I think that might be the wrong pointer. No, that looks right. 1629. Okay, is that not RIP then? Interrupts, source interrupts. Last interrupt frame. That gets frame. That gets regs. Frame. Oh, it's not. It's not. Yup. Well, thank God I'm not using that anywhere. I need to update. I have some 18s that I need to turn into 20s. Because I'm now pushing 4 things. So the 18s have to turn into 20s. The 20s have to turn into 28s. Whew! Oh, I was going crazy there. Now we actually have PC. Well, I did break my interrupt handler. There we go, 82. Whoa. I see. Well, I'm glad I added this PC tracking stuff in here. We're going to repeat 40. And we're going to get rid of these prints. And we should be good now. So we're now going to print the offset and then the value in RCX. And this will tell me the instruction that the interrupt came in on. And this is saying it's always coming in on 7B. And 7B, if we take a look here, it's this one. And RCX is 16. So we're going to go re-execute 7B, so that hasn't happened yet. So these are the amount of instructions that executed. This should be 16 inc RCXs. Vim, paste. It's 22? What? Oh, that's 16 hex. 16 hex is 16 plus 6, which is 22. Perfect. Okay. So 22 of the inks executed. So that's telling me, this is telling me that the instruction boundary that I interrupt on is accurate every time. So if I set an overflow to occur in one retired instruction, now we're back to doing research. If we set it to 1 to interflow after or overflow after one instruction, we actually end up executing this many instructions. Which is, or not including 48. So this many instructions. 1, 2, 3, 4, 5, 6, 7. By freezing that PMC on overflow, we actually lose that information. Yeah, we lose the amount of instructions that were executed. I could extract, is this using PEBs or the architectural event? This is the architectural event. I could try using PEBs. Let me see what I got here. Oh, I don't know if I have PEB stuff in here. Yeah, I don't think I have. I don't know if I have PEB support implemented in this. I have the fixed one and then the architectural ones. I'm not using the fixed counter right now. I'm using the programmed one to the PMC0. I could use the fixed counter. I think there is a fixed counter for instructions retired. I wonder if that one would give different results potentially. But so we know that the interrupt happened. I think I need to do more of these. I need to do like 1,000 of these. So we'll have 1,000 inc RCXs, and then we have the 1, 2. We have 4, or we have 2 instructions. We have this XOR RCX RCX, and then we have the so this will tell me let instructions executed is equal to 2 plus int regs.rcx. So compute number of instructions executed until the interrupt occurred. So I'm curious if we're going to be able to see a pattern in the like boundaries where the instructions, or where the if there will be a pattern for the locations, or like a pattern between the overflow distance and the instructions executed. So here we can whack these into, I'm just gonna print here. I'm gonna print insters exact. We're just gonna print this out for now. Just trying to reduce skid, yeah, pretty much. I'm actually trying to figure out if skid is deterministic, which is what really matters. Okay, so this is saying 7 instructions executed. We're about to go execute at 4.2, which is like way here. So 4.2 is 1, 2, 3, 4, 5, 6, 7 executed. Okay, so I think we have a good idea of how those work. And now I can do, I can get rid of printing out these histograms. And I can make a database of, let instruction request is equal to CPU rand mod 50 plus 1. Number of instructions we want to execute. Then I'm going to, we're gonna track these somehow. We're gonna do let mute request to actual is equal to vec. Oops, it's gonna be equal to a B tree map new mapping from the requested interrupt time based on performance counter overflow to the sets of instruction boundaries that were observed. Okay, and we'll just do mod 5 for now, and then here we're going to subtract off inst request. Might have to cast some types here. Okay, it doesn't know the type on that. Perfect. So request to actual. So here I'm going to do a request to actual dot entry for inst request or insert btree set new dot insert instructions executed. So update the set of observed instructions executed per different instruction request length. And that's all I care about now. We'll pretty print this into request to actual, and that might be ready, honestly. Btree set, okay, that's it. Btree set. Let's see what we got. Always, wait, that's always 29? That's always 29? So PEBS is for the hardware records the info so you don't rely on an interrupt handler. Yeah, well, I want to be able to interrupt at a specific location. That is the goal. Like, I can record the data. I have no problem getting a record of the data. That's not the hard part. The hard part is trying to determine a way to interrupt on the same boundary every single time into a running machine or application. That's really strange that I'm now seeing it always... Oh, there's 28. Let's see if I run it again. Always 28? I saw 29 sometime. I'm curious if the ASLR state can affect these. 29, it can. So CPU state can actually affect... I find it really strange that this is different than this. If I just do 1 here, set enable. Whoa. That's always 7. But if I do this, and I have CPU, what if I set that to 1? This should be 7 as well. This is the exact same effect. Yep. And what if I do rtrand mod 1 plus 1? This is the same as 1, but this will probably cause it to actually get put into a variable. Still 7. Weird. Mod 2 plus 1. $24. Why are they both 24 though? That's what I don't get. Set enable to that. I'm gonna set that to 100 for, actually I probably should keep that. What is that changing? So that then writes, is it because I'm using a memory operand to write MSR? No way. I'll be right back. I'm gonna hit that. I have a really crazy thought that the performance counter, like, that's a serializing instruction. The only thing that changes, right, between this, those are both 24. So let's scan up to a higher value. Let's scan up to, let's go up to 40. And let's see if it's 24 flat, and then it increases linearly. No. It's always 41? What? Okay, I think there's an issue with my code here. Inst request. Write out the perf counter. You're gonna reset perf counters, set enable. It's reading the same value off the perf counter every time because it's still frozen, isn't it? No, but then I'd see a negative number. If it were still frozen, dude, I'm really confused. Since I'm seeing the same number in all of them, that makes me believe that I'm causing the same value to be written in all cases. This went to 2. Is that actually what I want? 2. What is... It's always 0. Performance counters read. Reserved RCX. Well, I'm grabbing that from int regs RCX. I'm not hitting that interrupt again. That's what's happening. Let's do this. Int regs dot RCX is equal to leet clobber rat RCX. This will make sure that if an interrupt does not occur, I think that's what is happening here. So we're gonna do this. Mutable reference. We're gonna clobber it. We're gonna make sure that an interrupt's actually happening. I think the interrupt's not coming through every time. It's only coming through the first time. Yep. One of these has a 4-1. And the rest have leap +2. That means we're not getting an interrupt every time. And then here, assert that the int regs.rcx is not equal to, and we'll fill in just a random value here. Clobber. Yeah. We'll go to stream term Python import random hex random.rand int 02 to the 64. Grab this. We're gonna write that value into that, and then we're going to assert that this is not equal to this. No interrupt occurred. I don't know what I think I'm not clearing some state or re-enabling the perf counter correctly. Yep, no interrupt occurred. Perfect. So now we have a check on that. That's good to add. Disable no clear. Perfect. So we've got init, register, resolve, reset. Clears the overflow bits in status reset. And that sets counter freeze. On PMCV4, it sets counter freeze. Read fixed. Fixed counter set interrupt. Enable counters. Do I not have a way of clearing freeze? Dude, have I not been hitting interrupts? Freeze on overflow. Oh my god, dude. I gotta look at some of my old research to see if I was doing this wrong. I'm gonna take a look at it. This might dramatically reduce some of the noise that I was seeing. Huh. This is... What is this? Yup, tracing. Okay. Reset. Configure PMI on NMI. Yeah, so this is what I do. Reset. Configure. Freeze. Performance. Counters. Disable all. Set an interrupt and then clear. Okay, we're gonna do performance counters disable all. That sets this sets the static disable. Yeah, that'll write 0 in perf global control. Perfect. And perf global control is where the freeze is. Oh, that's in status. Enable that. That'll set counter freeze in global status. Does not change global control. It does in PMC less than that. Disable all. And then I then explicitly disable individual ones, which I don't think I need to. Oh, I see. I go up and I do disable all, and then here I disable these to clear them out. Disable and clear the perf counters. And then I program one by doing enable. I set that, and then I enable all the counters atomically. And then I disable all of them atomically as well. Compute the number of cycles which have occurred since that is overflowed. I see. Disable all, and then enable counters, performance counters, enable counters 1. All right. No interrupt occurred. I'm I-writing out of that frame correctly, I think. Unless I'm masking NMIs, or I'm not A-picking that correctly to allow another one to come through. So this will be like print good run here. After the assertion, I'm going to print good run here. And we're going to move this out of the marker. Now we're just debugging. I think it's only doing once. So the question is, am I masking NMIs? Am I not clearing? I think I'm not clearing that freeze. Performance counters reset. And that resets status. And that writes over clear overflow bits by writing status reset. And that will also, coincidentally, reset the, I think that'll end up resetting the freeze bit. Really? Really? I have no idea. Am I blocking that interrupt from happening twice? I think so. Source interrupts. I should iret, right? Pop iret q, good. So if I'm iretting, I shouldn't be masking NMIs. And then in my handler, I'm APIC writing B0, which I think is what I want to be doing. Maybe I don't want to. Dude, I'm so confused. Why am I not seeing those interrupts? Alright. That makes me believe it's still frozen. But run complete with val this. I see. I think the enemies are not happening. And I don't know why. I think the perf counter is still operating with 6 and 6. Complete with val 6. That minus that. Enable that. Freeze on overflow. Let's do this. What am I doing? Complete with that. No interrupt occurred, and that was on the first go. Yep. No interrupt on the first go because I didn't enable the counter, which I need to do with that. That's the global enable. Run complete with that value. What? Performance counters, resets, and disable all, and then we'll disable the individuals at 0, 1, 2, 3. Otherwise, I can pull up the manual and stop guessing, but I feel like this should work. There you go. So that one works. All right. Perf global status. Clear overflow bits via reset. We write the value of global status as each bit that is set will trigger a clear. Yeah. So by doing a reset inside of the loop here, that'll make sure that the counter freeze bit gets cleared. This sets counter freeze on an interrupt. I think this is right. I think I'm just not seeing the interrupts. Value 7, value 6. That was cool. Disable all, disable, reset. Go to status reset. Read the counter. Program is that. ID to value. Does not enable the counter. PMI on overflow. Enable the fix counter. Oh, that also enables fixed. If I do if I do enable counters 1 shift 32, I can then performance counters fixed counter set interrupt on fixed counter 0 and program it to value, so 0 it out. So this will program the fixed counters. I just want to see, because I know I used these in another one. I think it's delivering the interrupt, but for some reason, what do we got here? Unhandled exception. Let's just enable, let's do 1. This is the cycle count perf counter. So that'll set the value and enable it. And then we can then enable the counters. This will just enable the fixed counter only. Let's see what we got here. I'm close to just reading the manual. Why is that causing a... Oh, 32. Yeah, the right MSR. Okay. That makes sense. Yeah, the right MSR was causing a general protection fault. Or probably, what was that, a 13? Okay. No interrupts. Yep. Cool. So now we'll set the fixed counter to 1 shift 48 minus 1, which I think is what I want to do. Okay. Oops, should probably build it. So that should set it 1 away from overflowing. Is that what I'm using? Read fixed counter, disable all, get the status. Maybe I might not have been using interrupts in my other example. Well, that should overflow. Oh, whoops, enabling the wrong one. OBO 1032. Same as shifting by 33. This should trigger at least 1 overflow. And it did, so we got 1 overflow, which is good. And then we're not seeing the other one. Yeah, I'm pretty sure for some reason I'm not acknowledging that interrupt correctly. I'm kind of surprised. Using NMIs maybe is like breaking this. Source interrupts. If we got an NMI, then we write to APIC B0, which should be good, and then we return out. Yeah, we're definitely hitting that NMI. Returning out from this function. I'm trying to think if I... Yeah, definitely IRAT. Maybe having an NMI triggered from a performance counter is just undefined behavior. NMI. So that's going to write to the APIC, and that's going to cause it to generate 100. This is the interrupt type, I think. Let's take a look. Intel manual. Let's go into the system manual. And then download bookmarks. Is there no way to like have the bookmarks open in Chrome? It's really annoying. It's really annoying. Let's see, where's APIC at? It'd be nice if it weren't so narrow too. We're gonna open this in Firefox, a browser that actually has a reasonable PDF reader. Hopefully that's not gonna keep zooming on me. I think it is. It's going to. Well, we'll deal with it. And then we can collapse everything down, and we'll go to APIC. Not APIC virtualization. We just want the standard APIC, which, where do they write that now? System resources, VMM, CA, APIC, right here. Okay. Local APIC and IO APIC. Care about the local APIC. Let's take a look at the block diagrams. Let's make sure. Local APIC state. Local vector table. We got the performance counter register here. Specifies the interrupt delivery on a performance counter when the performance counter generates an interrupt on overflow. LVT entry is implementation specific, not architectural. If implemented, it is not guaranteed to be. Really? Is that new? That's interesting. Any performance counter that can be configured. Let's see what we got. PMI if the counter overflows. PMI blah 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 can collect information about the state of the processor. Can be used with vtune. To enable that, you set the overflow PMI flag in the CCCR MSR. When overflow occurs, a PMI is generated through the local APIC. Here, the performance counter entry in the local in the LVT is set up to deliver whatever. PMI service routine can use the overflow flag to determine which counter overflowed. While generating interrupts on overflow, performance counter preset to that value, blah, blah, blah. Number of events counted +1. Yep. Put a negative number into their cascading counters. Oh, interesting. Can you just do a straight negative? Well, then overflow counts 99 events. Generate an interrupt on the 100th. Difference of 1, blah, blah, blah. Because of the latency and generation of events and blah, 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 it's sometimes difficult to get it close to the event that caused it. These situations, the force overflow flag can be used to improve reporting. Ooh. Setting this flag causes the counter to overflow on every counter increment, which triggers an interrupt after every counter increment. That's interesting. Force overflow? Huh. At retirement counting. Blah, blah, blah. Okay. So where in the manual does it specify where to get this this base address? It's just a standard a vector thing. So I'm shifting an 8. I'm setting it to what am I shifting in? Yeah, 108. So that is we got an NMI that we're smashing into there. So I'm saying I want an NMI to trigger with a certain vector of 0. Delivery status. Masked and not masked. Oh, do I have to... I gotta clear that, don't I? Will that get masked when it gets hit? Configure PMI to NMI. Do I have to APIC write that out? I bet this will fix it. I think that mask is being set in the local APIC, and I guess my interrupt handler doesn't clear the... Yeah, there we go. Okay. Cool. So now we're getting an interrupt every time, which is good. Now we get rid of all of my debug print shit. So that'll reset the APIC to be in a happy state, and then we'll set enable this, enable counters 1, reset, disable all, configure those, and then this, set enable. Actually, we'll just enable that. And then here, reset. Reset will clear the flag. That will... So it'll be disabled. We'll call reset. That'll reset the freeze flags and reset the overflow condition flags. We'll then configure the PMI to cause an NMI, causing the APIC to be in a happy state. We will then write in -1 for the counter set, and then we'll set enable that. And I think we should be counting now. Geez, that was a little mistake. I could also clean it up by making it a little bit more direct. Okay, cool. So we're seeing different counts there, which is interesting because we're setting the same boundary here on the interrupts. So 148 minus inst request. And let's see what we have for correlations here. All right. So when we want to stop in 1 instruction, we stopped in 7 instructions. When we wanted to stop on 2, we stopped on 28 or 29, 3, 28, 29, 33 if I wanted to stop on 7. Do these ever go down? Interesting. Wow. Huh. Okay. I'm gonna not pretty print it. See if I can get this. We'll do this. For request actual in request to actual print request and then actual. We'll format this with 5, I guess. That'll be fine. Okay. So I wouldn't expect that it... Okay. So it's kind of always going to increase, but I bet to a point it stops increasing, and I bet that's microarchitectural. I bet that is the processor flushing the speculative window that it's currently executing. So... Okay, I think we're going to see a really cool heat map here. Yeah, we have the actual number. We can read the perf counter. The perf counter will always be 0, I think. Assert counts is equal to 0. I'm just going to throw that assertion in there because I think the counter will stop on overflow on the actual boundary. Oh, nice. Count is this. Count. Okay, this is behaving more like what I expected. So, I think it's going to keep counting. And thus, I'm going to do a panic instructions executed and then the count. and count, and what do I have? Inst request. All right. So that counter is going to overshoot. Pretty sure. Whoa. Oh, just a bunch of unused shit. Okay, so we got 43, which was the actual numbers of instructions executed. We got 5, which was the performance counter, which overshot. Fix counter, set interrupt, reset, set enable. Set it to that, enable it to track retries. Configure that, PMI to NMI, freeze on overflow. I was kind of hoping that these two numbers would actually add up to 43, but they don't. But that's another one that I'll be interested in tracking. So, freeze on overflow. $701, okay. So that's saying that the counter was frozen when it became... The counter got frozen when it hit... The counter got frozen, it executed 6 more instructions than expected. Because it overshot by 6. I'm going to get rid of this disable. I don't want that disable there. I want it to just... Yeah, I want to be able to verify... 3259. So I requested 9. The interrupt came in, and then I had 9 as the count. Or 5 as the count. So I wanted 5. That means the counter ended up increasing for, what is it, 9. We set it to -9. So, yeah. That's really strange. Because I would hope that the counter would stop when the interrupt gets delivered. And I could try using different counter numbers. Configure PMI on overflow. Okay, reset. That clears the overflow states, which allows them to count again. Freeze on overflow. That minus inst request. Set enable. Perform that. Okay, so we're going to ignore that for a while because that seems really interesting. And sometimes it was 6. I was hoping that we'd actually have an accurate count. Maybe I don't. 392. Whoa. Whoa, 392 is... First of all, I'm going to move my marker. Oh, fix counter set. Oh. Whoops. I had another counter running that was also going to trigger overflows. So, reset, disable everything. Enable only that one. I think the other one wasn't enabled, so it wouldn't have triggered overflows. Okay, so these 392s... The 392s are, that's 186, I'm guessing. If I do, what was it, 186? 186, that's 390, yeah, 392. So this is saying when I request reset, configure those, freeze on overflow, I'm going to do disable all every loop iteration. So I'm going to do disable all, reset. I don't need to do the manual reprograms. I don't want any of this, actually, except enable counters. So, all right, here's what this is going to do. This is going to disable all the performance counters by setting the global performance counter to all 0. So that disables every counter, including the fixed ones, including the crazy manually specified ones. Then we're going to reset the state of everything. So reset is going to reset all the counter overflows. That's also going to clear freeze. Then I'm going to configure the NMIs. That's going to re-enable the interrupts. So that'll give me access to interrupts again. So I'll be able to actually have my interrupt handler get hit. And then I'll program freeze on overflow, which will cause me to... that'll cause all the counters to get frozen on an overflow condition. And then I'm going to enable one of them and program it in the same go and set it. So I'm going to set it to a value, I'm going to program it, and I'm going to enable it. So in this case, I shouldn't see an interrupt. There should never be an interrupt. This should panic. Cool. No interrupt occurred. Perfect. And then if I enable counters here, that's only going to enable the single one that we want to track. So all the other counters will be disabled. So that's like a full reset state. I'm much happier with this. And we get an interrupt every time. Okay. So now we're seeing the like 724, 2929, that pattern again. What's interesting is that by changing the shape, so what does this have? This is, where's our marker? We're going to move this up here because that's programming it. All we care about is this enable counters. I think depending on the way that you enable the perf counter, you get a different boundary. Yep, so there's 724. And then, yeah, we're working in undefined behavior land right now, I think. Yeah, so if I just put in a time sleep 500 here, so that's a busy sleep, but we haven't enabled the counter yet. I'm just using that to kind of change some of the microarchitectural state. Let's see if these numbers change. Nope, still 724. Okay. Because I was seeing it break in on the next instruction itself. 724, that's the same. Standard mem read volatile from 0 as mute u8. So I'm gonna read from core pointer. I'm just gonna perform a read from null, and that should hopefully cause like a little bit of a delay and potentially change some of these windows. No. What if I do 2 reads? Nope. Still seeing the 724. What did I do? It was this state. In this state, I think I could see the counter prior. Yes, this has 392s. That's so strange. And what did I change? So I'm going to grab that fix counter, and we're going to put that in there before we enable. I'm just going to do that and see what this does. That's technically another serializing instruction. Okay. So this is the one, like the code shape seems to matter, which is bizarre. I'm 30 years old. Can I learn to code? Of course. I can learn to code at any age. 30 is still plenty young. Apparently the fix counter keeps counting through the interrupt and traps according to the Intel manual. Maybe that explains it. I'm not quite sure because I'm not using the fix counter. So I'm gonna try and process of elimination. I think this is, I don't think it's has anything to do with actual counters or logical behaviors of the code. I think it is literally like internal states being different. Yeah, there we have 392 without that. And 392 means that we're actually breaking in, that means we're breaking in before this XOR. We're breaking in on the next instruction, which is kind of bizarre. So that does a set enable. Maybe setting it directly through here. Let's see. So I'm going to bring some of the things that I wanted. Disable all. And then here, I'm going to enable counters this. See what we get. Okay, that's back to 7. So the boundaries are different depending on how you enable the counters. So if I do, what if I do this? Well, I need the disable all if I want the enable. So I can get rid of that completely. So yeah, if you use the global enable, you actually get different results than if you write directly to the perf count MSR. That's basically what I'm seeing. And then it goes to 7. And then it starts to kind of spread out and get wider. And then here, if I disable all, enable counters. Doop. Yep. And if I don't do this, it should panic because there won't be an interrupt. I just need to make sure that it's not counting. But yeah, writing directly to the yeah, enabling via not using global actually changes things. So disable everything, disable all those counters, configure PMI, freeze on overflow, enable counters 1, and then we reset. I want to disable 0. So there I'm going to disable. That'll disable the counter that I'm tracking. Everything's been disabled in this case, so when we loop around, I'll disable that perf counter again, reset, and then we'll reprogram it, and let's see what this does. Okay, that puts us back to the 7. And that's just adding the disable there? Whoa. Whoa. Nice. That's what I like to see. So if we call disable on that MSR. Okay, now let's see if we do disable all and enable counters. Something about disabling the counters is probably like resetting some state inside the CPU. Yup. Yeah, so if I disable it, and I think my disable will clear it, and then also it'll clear the count register, and oh, that's 7. Is it literally just ASLR state? Oh, this one has disable. Yeah. And then if we get rid of disable, which will get rid of clearing it and get rid of writing zeros over the perf counter, then we see 392. That's so weird. What about disable no clear? So disable no clear, this is literally just going to write over the perf counter control register for this performance counter, perf counter 0. It's going to write over it with a 0. It's going to leave the count the same. So the count's going to persist. It's just going to write over that. Yeah. That probably causes delay in... That probably causes delay in the... like, writing to that probably causes it to, like, reevaluate itself internally. So we'll do time sleep 5,000. Let's see if we wait it out, if we can get the 300 back. So we're going to wait it out, and let's see what we get. Interesting. Dude, that, like, dramatically changes the internal state. Wow. So writing a 0 to a performance counter and then re-enabling it is different than just leaving it enabled. Huh. What's interesting is I'm getting interrupts on 392. Let's take a look at what that actually is. Whoa. That means that we're, like, priming the perf counter stuff? Dude, I have no idea. If instructions executed is equal to 392, we're going to panic and we're just going to dump out PC. And this will be rip offset. Oops. Oh, this is kind of cool. 392. Oops. If it's equal to 392, then this will print the PC of the interrupt. Let's see what we get. 22. It truly is. It literally is. In the case that you have 1, 2, 3, or 4, we are getting a perf counter overflow interrupt prior to any instructions executing. Prior to 4 instructions executing. What? What? Oh, is that because it's still counting? It might still be counting. So we set enable it, we enable it, it then gets frozen on the interrupt, then we come back around, I reset, which will unfreeze it, it'll start counting again, I configure PMI to NMI. Set freeze on overflow. I think I'm just adding artificial delay here. I bet these add up. Yeah, that's what it is. Yeah, I need to disable and clear it. We're going to do that. We're going to disable all. Yeah. We'll disable everything. We're going to reset the overflow flags. So, yeah, I think I had it counting there. Okay, this is much better. Cool. Yeah, I had it counting when it came back around because I reset it, which cleared the freeze flag. So then I probably triggered an overflow, and then I ended up like zeroing it out again, which then caused it to be in a really weird state. So here, disable all resets. That'll clear the freeze flags, allowing it to count again, but it won't because it's disabled. I fixed the NMIs. I messaged the APIC to fix that. I set freeze on overflow. I reprogram the counter, and then I enable it. So this is much more correct. Yeah, that was the issue. Is we had an interrupt that was going to be coming through. Okay, so this is the only data we care about are these sets. So now I want to increase the number of runs. Disable, reset, configure PMI to NMI, freeze on overflow. That's already set, and that's a permanent. Yeah, that's setting it in debug control. That's not going to get changed. Then here, change the start marker, get the set enable, move this down, paste this here. Clobber. Then we have our 1,000 things here. Okay, now we want to start collecting data. Let's go to 250. I also probably need to add like a loop counter. Yeah, we'll do this. Like under II, at the very end, print this iterations complete II. This way I know approximately how many things went into my data set. Because if it's a low number, then I probably don't have enough data. So this will tell me if I'm actually like getting many iterations through here, which I probably am. I'm probably getting like 1 million a second. Yeah. Interesting. So I see basically 2 different values that I can get on perf counters. Oh, I'm loving this data. Oh, this is going to be good data. I think we're looking at speculation windows right here. I think that's what we're doing. I think the perf counter interrupt comes through. The perf counter then signals the processor to generate an interrupt on the next retirement or something like that. And retirements happen in batches because the retirements are happening in batches because of speculation. And all of these numbers are greater than the counter because it always overshot, but then it has like a linear shape to it. 6 million iterations complete. So here's what we're going to do. We're going to say if II is equal to 10 million, if it's greater than 10 million, I'm going to write all of these out. And I'm going to, there's some like flags I can use here. Let's see. What is the script looking for? Vim runner. Start CSV data, end CSV data. Print start CSV data. End CSV data. So this will cause it to get downloaded locally. It's probably gonna maybe try and graph it. It's gonna get confused, but whatever. And then we're gonna make a really cool heat map. So this is going to take a while. There we go. We found the data. Data mismatch from header. I think that's fine. arm star.text. I actually need to re-download this. I can relook at this script and see what it actually outputs, but... There we go. Data inbound. Raw data. Fuck. Runner.py. If that, waiting for end tag. If found data. Generate graph, CSV parse. That's going to get the column names. Yep, so we're gonna copy runner.py. We're gonna make perf counter test.py. CSV data, buffer.find. If it found that, found data. Generate graph. Get rid of this shit. Regraph. Get rid of that. Okay. Find all. While true. Wait for response. Search or find all. That. Found special payload. Payload is payload 0. That's going to find the first occurrence of that. And then we're just going to open data.bin write binary.write payload. And we got a dot all on CSV data RN. Perfect. So it's everything between those 2 points. Non-greedy match. Python perf counter test. Oops. Python. Okay. Now we should have the data in data.bin, and then we'll work on a parser for this, and then we'll turn it into a heat map, and we're going to see what the associations look like and see if there's any patterns. Data.bin, okay. So that's literally just the raw data that's shipped out, so we're just going to do this. We're going to print the request, comma, for ent in actual, print this, comma, int, and then print new line. So now I'll have the request and then all of the different entries. This will just be a little bit easier to parse. Burp. So we got there we go. Data.bin. Yep. Okay. And now we just want to parse this so we can make a heat map. How do I want to do the heat map? X-axis is going to be the cycle stop request. Y-axis is going to be the frequency that we saw a value. Yeah, I need more data here. I need more data here. We're going to make this, we're going to hijack one of these observed counts. Observed counts. Count is equal to that. This is going to be int regs. Okay. Rip offsets. Observed. RCX. Don't care. Don't care. Inst request and instructions executed. So inst request and instructions executed. So we're going to get that entry or insert 0. So this is going to now have a mapping of the requests to their frequency, or the request mappings to their frequencies. Then we can go through here and we can say request actual. So this is the requested actual frequency. Request. You know what? I might be able to just go directly to a graph here. Requested actual and frequency. Oh, it's not request to actual. This is let's see what we got here. This is observed counts. Get rid of these. Observed counts. All right. So we let that data come in. How long is this taking? Like 5 seconds, couple seconds. Okay, that one took a little bit more time. So we've got data.bin. Okay. Ha! It's what I kind of expected. Some of them are lower, which is cool. That's kind of what I was expecting to see. So, let's see, what do I have here? So, I don't think I can directly graph this because I think I need all of the data missing. Or I think I need the missing data included. But let's try it. Plot vim plot. We're gonna plot perf counter dot plot data dot bin using 1, 2, 3. With image set term WXT, I think. Because I think QT was not working. GNU plot p plot perf counter dot plot. Okay, so that's not working. And I think that's because, wait, WXT? Oh, I can't remember what my fix was the last time I had this problem. Vim data.bin. I'm just gonna delete this data. I'm gonna do like 115.125.215.225. Okay. I think maybe it was QT. Vim plot perf counter dot this. Set QT. I'm just trying to figure out if this doesn't work in QT. No, it does. WXT. All right. Then that means that the ordering might matter. Okay. Data.bin. So I did this one on the outside loop, and this one on the inside loop. I just need to get these loops to be identical. So we'll do like for this in for x in 0.500, for y in 0.500, print 5, 5, 10 of x, y, observed counts dot get x, y dot unwrap or 0. It's really gross. I should technically have it figure out the max, like the limits of the test. In this case, we're going to 250. Let's bump this up to 450. I don't think we're going to miss any data with that. But that will generate a full grid. What did I do? Reference this. Unwrap or 0. That means we have frequency 0 in those spots. Yeah, because I think it expects the... It expects that entries can be... I don't think it can handle sparse entries, GnuPlot. So now this won't have sparse entries. And then hopefully we have a graph. Hopefully. So that's generating all that data. Relatively low cost to do that. Waiting for the end tag. Data gets dumped over. What's 500 times 500? Did I just print a lot of data? 250,000 lines. Oh boy. Times 551110. This is 5.5 megs of data over multiplied by 8, 115, 200. This will take 381 seconds. Okay, so that's not gonna cut it. We'll drop this to 100. We'll go down here and we'll go to 150. All right, now it's less data. We can always generate it on the Python side. It's just a network transmission bottleneck because we're using a serial port. This should fit a lot easier. Yeah, waiting for end tag. How long will this take? 150 times, let's say 20 bytes times 8. Yeah, this will take like 30 seconds. I should just send the sparse data and then reconstruct it in Python, but this will do for now. Unless it's actually not running at 115,200, but it should be. But maybe Pixie like kind of breaks some of those semantics. So disabling all, resetting, configuring PMI, set enable, then enable counters. There we go. Data.bin. Please plot. Nice. Nice. And then vim plot, perf counter, size 1440 by 900. All right. Interesting. So this is all of the data. So I wonder if I get rid of those 0 lines. Let's make a copy of this first. Data copy.bin, vim data.bin. Go to lines containing a lot of spaces and a 0. Actually, just any line ending in a 0. Space 0, and delete them. Okay, oops. The opposite. I want delete lines There we go. So this is the sparse data, and for some reason, plotting images doesn't work with that. Let me see. GNU plot image. There's gotta be a way. Oh my god, they updated the demos. They updated the demos to have Linux, to have Tux now. They didn't used to be this. Wow. Wow. That's pretty funny. Oh, that's so cool, man. Okay, but I'm interested in image. Oh, that's some blog. Gotta love Tux. Yeah, man. I just want plot command. Let's see. Quick reference. Documentation. GNU plot docs. Thank you. Oh. Are they now only in PDF format? Okay. Then this is the official version then. Plotting styles, image, RGB image, and RGB alpha. Let's see. Plot matrix with image. Okay. If I did matrix, that would save a little bit of space, but it's not exactly what I want. So matrix, it'll derive the XY. What else? Plot that. Matrix with image. Each pixel of the input 2D image will become, god damn, that zoom, man. The coordinates of each data thing, blah, blah, blah. Flip X, rotate. X and Y extent of each. See, binary keywords. To generate a figure at the right. DX, DY, and origin. Input PNG. With image pixels. Pixel by pixel. Dude, there's gotta be a way. GNU plot image, sparse matrix. Plotting sparse data. Oh, I mean, I see. You know, that's actually, that applies a function and then plots with circles. Dude, that is so cool. That makes a lot more sense. Plots, perf counter. Plot data dot bin 12 F3 LC palette. Woo! And I get the, oh my god, that just works. Fuck yeah. Let's just drop that size down a little bit. Oh, that's the transparency. Oh man, we're making some fancy shit now. Circles, I'm gonna set the size of a circle. GNU plot circle. circles. LT3. Is that going to change the thickness? Nope. LT1. Nope. Okay. Solid 0.5. Oh, is that the size? Do I just give it the size there? How to... Using that... Oh, is it set by the palette? This one. Is it that one? No, that was the transparency. No border, transparent. Plot a circle with a radius. Oh my god, no. Plot circle with circles. And that's what this is, with circles. Third column can be used as a radius. Ah, that's the radius right there, 0.5. Hey! How is there overlap with the radius 0.5? Wow. Why would a radius 0.5? That's a radius... That's a radius of... Oh, it's 0.5 on the x-axis. And then that's centered around 49. How do I get them to not overlap on the y-axis? Am I giving... I'm confused. There we go. Wait a minute. Zooming in like that fixed it. Oh, it's because I wasn't outputting a square, I think. If I do 900 by 900. Yeah. Oh, that's some nice data now. Data.bin. And now we can do the sparse data. We can go back to this. There. Cool. Okay. Oh, that's so cool. All right, now I need to switch to a different palette. Dude, this looks so cool, this graph, man. What an awesome way of visualizing data. Now what I might do is I might switch it to the deltas from what they are. I love these colors. I gotta say I love these colors, but they're really hard to interpret. So first of all, I'm gonna set this to non-transparent. Actually, I want maybe like a... No, I don't want any transparency. Okay, so that's the standard way of graphing, and then this is the standard distribution for the heat, the frequencies. I might want to do like grayscale or something, because as a colorblind person, it's kind of hard to interpret this. And then... So for those four, yeah, we can see it like jumping up. This is linear. So at the start, things are like grouped in 4s, and then they're grouped in 2s. Is there a pattern here? Is there a pattern here? I might do a subtraction. I might subtract this is now going to plot the delta from desired. So for the very first one, it was off by 6. And then everything else, oh my god, dude, look at that. And then it gets like very chaotic. Huh. Let's see if I can zoom into this. So we're ignoring the first data point, which is off this chart. So this is the interrupt inaccuracy in the perf counters. First of all, gotta say, this data is beautiful. Love it. Really cool. And then here we see it striding down. Huh. I'm not seeing any, like, crazy patterns here. I feel like the other one was a little bit better for seeing patterns. Yeah. Let's get that nice and zoomed in here. Send it to 7. You know, I should learn how to get GNUplot to resize. Does that work? There we go. Redraw continuously while resized. All right, what is that setting then? Redraw continuously as plot is resized. Redraw continuously as plot is resized, GNUplot. There's got to be a flag that I can set. Pause, reread. I don't want it to refresh the data. I just want it to handle resizing. It's clearly a flag that's going to be... It's an option that you probably can pass to WXT. WXT options GNUplot. Put the window at the top after each plot. Output terminals. Size enhanced. Font persist. What is persist? Oh, persist means I don't have to do -P. Okay. GNU plot term option. Sorry, I'm just looking off screen because I thought this was gonna be easier, but apparently not. But I would like that to automatically get set every time I plot, unless that's a permanent effect. It is. Okay, so we're just fine. All right, so let's pretty this up. Set grid, set X label, performance counter requested instruction boundary, set Y label actual interrupt boundary. Okay. Set no key. Nice. And then how do I get it to fit and not round up? GNU plot fit data exactly. Fit data. Unless I set an X range, but I don't think I did. Vim data.bin. Yeah. Set X range 0:. Set Y range. And they should both start at I guess 0, 0 is fine. But I want it to not add the, I don't want it to add these extra, the extra space here. GNU plot auto x range, min max values, edge of the plot border. They're a little beyond data because it leaves a little space. I know I've done this before. I don't have it memorized. Hey HL521, how you doing, man? Auto scale. Auto scale. Auto scale Y. Only for the minimum. I don't like that. I'm losing a lot of information by having that. It's frustrating. GNU plot, no X range padding or something. X range does not affect that. I'm using the fit command. I don't know, we'll make this work. Is this I3? No, this is DWM. Good old-fashioned DWM. That's all you need. At least all I need. All right, let's take a look at this data here. And what do we got here? Isn't DWM from Suckless? It is. So So basically, this is saying that 100% of the time, if we ask for one instruction, I get 7. If I ask for 2, I get 22 or 23 or 24. And then let's zoom in a little bit in this range. Let's look at the start of the data. So this is kind of the start of everything. And the color shows me the frequency. So I can see if there's a pattern. We can see that 23 is less frequent than 24. And then up here, we can see that this orange is more frequent. So the frequency actually is in this range. If that makes sense, it's kind of interesting that there's orange to orange. And I think that is telling us some like sub instruction information here. Because if we went by frequency weighted value, this would be biased towards here, and this would be biased towards here. So this one's biased upwards, and this one's biased downwards. What's interesting is that for 7 through 14 instructions, it was a fixed value. It was either 33 or 37. What's interesting is we never actually see it decrease on the graph. We never see, at any stage, we never see it go down as the instruction counter goes up, which lines up. That's kind of what I would expect. Are you using surf and ST as well? What's surf and ST? I don't think so. Oh, is ST the terminal? I'm just using Xterm. I've always just used Xterm. That's kind of what I'm used to. Okay, and then here, let's take a look at these. So here, I expect that in most of the other ranges, we're going to see sandwiches. So here where we see 3 values, we see it's hot here, and then a little bit on each side. And same thing here. This one, this got hotter, and then that got moved up. It's really weird, man. That is really strange. I really want to add like a frequency weighted value. I think I'm going to run that through. ST is suckless terminal. And then we're going to up this next run. We're going to go to 50 million so we have more data. And then frequency. Okay, so we're going to plot for requested actual. So we have to do another one. Suckless are pretty good at writing simple applications, but they're never terribly performant. Case of ST. Yeah, Xterm is like super fast, which I've liked. Surf is making it easy. Huh. How much shit is being thrown into Firefox that's not needed? Yeah, that's so true. Firefox is getting bloated, which sucks. And all the new browsers are equally bloated. There aren't like... No one's really working on a thin browser anymore. Which makes sense, because nothing works with a thin browser. Alright. We're gonna do... I guess perf is not hugely important here. Let mute. Actually, I'm going to change observed counts for X. So we're going to take inst request. Inst request dot or insert hash map new dot or insert dot entry instructions executed dot or insert 0 plus equals 1. Okay, so we're gonna have on the outside we're gonna have the requested values. Then we're gonna have on the inside we're gonna have another hash map that's gonna contain the instructions that were actually executed. And then I'm going to keep a frequency of all of those. So then I can do for requested, and then for requested actual. Can I do all of these in one go? I think so. For requested actual frequency. Ooh, actuals. I actually want this. Actuals in observed counts. Let actual sum is equal to actuals dot keys dot vals dot sum. So count up the total observed values for this requested instruction count. So we got the actual sum. Then for actual freak in actuals, we can do this, right? This should be valid as is, or very close to. Yep, hash map. Yeah, that's a B-tree map here. Chrome uses Blink now. They forked WebKit. Yep. Hate search software like Ubiquity that develops specifically for Chromium browsers. Yeah. Okay. Did that build? Yeah. Oh, wait. No, it didn't. Vals. Values. It's probably values. Give actual sum a type. U64. Oh, yeah, that's the first type instance on those integers. Oh, interesting. Okay. Wow. Yeah, so this... Okay. Yeah, that typed this. That didn't have a type prior. Interesting. Okay. Actual sum U64, and now we can do frequency as F64 over actual sum as F64. And now I can get the 10.8 Now I'm going to have the frequency relative to its request. So then my heat map is going to be in percentages of the current distribution. Then I can also plot two more things. Weighted val OF60, actually let's weighted val equals actuals dot values dot iter dot fold. OF64 is what it starts out as. And then I'm going to take OF64 starts out as that. I have the accumulator. I have the actual and the frequency. Go through all of those. Okay. The weighted value, we're going to go through all of the actuals, and then we're going to do let freak, or this, let freak is equal to freak as F64 divided by actual sum as F64, ac plus free, actual as F64 times frequency. So fold that, starts out as 0, go through all of the things, figure out the percentage, and then multiply the percentage by the actual value, which is the y-axis, and then here we can just add that as another 15.6. And then this will be the weighted val. I guess ref both of those individually. Can't cast U64. Wait. Ref U64. Here. Zoop. Alright, we're making progress. Unify video even has better support on this now. Oh, cool. Alright, here we go. We're gonna have a big data coming in here. Big data. Big data coming in here. Somewhere. Okay, Python perf counter test. Alright, this is gonna be a big set. Damn, out of runes. Out of runes. Oops. Doop, 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 doop. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Alright, and then this character needs runes. That's fine, the data's coming in, so I actually can be distracted right now. Oh, is that my data? 1, 2, 3. Doop. Nope. Okay. Eat my food and go here, and we should be good. Okay. All right. Data is in. Let's take a look and really? Why won't that plot? Let's get rid of the force ranges. 1, 2, 0, 5, 3. 0 to 10. Replace spaces with more spaces. Is that the issue? No? Are there too many dots on these things? %s 2 spaces with 1 space. Whoop. Yeah, there we go. Why won't it plot this? Feel like you're in the Northwest US? Yes, I am. Yeah, I'm in Washington. Why won't it plot that? I'm just gonna do a plot data.bin u12. Let's just try this. Okay, that data's there. 2, 3, f. If x is greater than 2, interesting. West Coast stream represent. If that is greater than 2, return x. Otherwise 1 over 0. Why? Yeah. That works. Does it? Yeah. I don't know what this crap was. I don't know why there's a transform being applied to it. There's just no reason for that, to be honest. Okay, and we ran that up to 250. So it starts to become deterministic at some point. Look at that! That is so weird. Huh. Okay, and then I'm gonna plot data.bin using x4 with lines. Whoops. Okay, that's gonna be, just plot it. I think I want to make like smaller dots here. 0.2 with circles. And then can I make it like black always by doing this? Or something? Whoa. With circles. Let's see, palette. I think I want to do 0. All right, now we got data. Now we got data. Okay, so what a graph style. I like this. This is actually pretty interesting. Oops. Reopen that. I'm gonna zoom in down to here. Okay, so the way you read this graph is the x-axis is the number of cycles away, or the number of retired instructions away from a perf counter overflow that was put into a perf counter. The y-axis is the the actual instruction where it stopped. So I requested to stop on instruction 1, and I actually stopped on instruction 7. The color indicates the frequency in percentage for that value of where it falls. So like the yellow basically means that 100% of the time it's that value. And then if there are two different values, you'll see the colors corresponding to the frequencies. And then the black dots are put in the location that is the weighted average for that instruction boundary. I actually really like this. Yeah, so like here, you can see the two different dots, and it's biased a little bit more towards the red side, which makes more sense, because that's the more frequent compared to the pink, which is less frequent. So, okay. What's interesting is that, look at this pattern. Dude, that's bizarre. I guess I only care about up to like here. We'll look at this area here. It starts to become deterministic. It's not accurate, but it becomes deterministic. It 3.3.3.3. What on earth? What causes that? Okay, I'm gonna subtract off. I'm gonna actually I can't right now. Let's see if that pattern continues. Let's go up to 1,000, and we'll set this back down so it goes faster. So this will be 1,000. Each point will have 10,000 points of data. I think that's plenty for the data. We don't need much more than that. Cargo run. Oops, gotta run it. There it is. Feel bad for completely ignoring this stream and homework doing like 30 minutes. Oh boy. Writing scholarly documents in LaTeX is super refreshing over Office suites. Yeah, writing anything in like a programmatic... Oh, no interrupt. Woo. 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 Yeah, we just need to like add more instructions there, I think. Yeah, we'll just add more instructions. Because where are we going? We're going to 1,000? Oh, so we should be able to get by with 1,050. And then we don't actually disable the counters, so that's just right up to the end. So we have 1, 2. Nice. I guess I can manage my runes now. Oh, that data's already in. Up. Uh-oh. Uh-oh. I see weird behavior. So it looks like in this center range, it's... Whoa! It's like slowly creeping up each one. Dude, what is that data? Are you gonna set this to like 1.5, 1.2. That's gonna make too much overlap. Okay. 0.2, 0.5. Actually, we can go like 0.8. What? 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 Oh, I want to do 0.5 radius, not 0.8. 0.5. Okay, so it starts to get like really chaotic for some reason towards the end. That one makes sense, I think, because maybe I need more of these. Was the actual? We're hitting actuals up to 1020. Let's just add more numbers. Maybe we're starting to get to like the end of a. Maybe we're just starting to have too many instructions that we're hitting the end of like a page and we're getting different behaviors, like straddling a page. I mean, we're writing a lot of instructions here. In fact, I'm gonna change these from an inc RCX to an inc ECX. That's gonna decrease the size of the instructions from 3 bytes to 2 bytes. So now they're gonna be 2-byte instructions. Takes up a little less space. And 32-bit operations are faster than 64-bit operations. All right. Data. When I get done with my homework, I want to talk some serious shit about my CS professor. Also, if you are a pen tester, do you have a security clearance? If not, do you need someone to help you out with that? My TSSCI just expired, but I can probably help. Especially since I'm sure Everett, NAS, and Joint Base need pen testers there. Interesting. No, I don't have a clearance. I'm just working completely private. So. Oh, and wait, now everything's green. Let's look at the low end of the data. Whoa. Now everything's deterministic? In this run, everything was deterministic. Everything's 1.0. What the fuck? Ah! Is it the 64-bit versus 32-bit? I guess we have to rerun it and see if we get different results in different runs. DD contracting pays through shit for pen testers. 6-figure job if you have the clearance. I'm familiar with it. I'm hip. Dude! Oh my god, that's 2 runs fully deterministic. With 4 instructions per cycle, assuming the counters get updated per cycle. That would make sense because we went from an even number of instructions to an odd... Oh my god. Oh my god. That is a brilliant idea, Lambda Perf. But I think data.bin, deterministic, all the way through. Check this out. I'm going to put this back to an inc RCX. And this is going to be, this is not going to be deterministic. And then I'm going to add a NOP in there, and I bet it will be. I bet it has to do with the number of instructions in the, like, I don't know. All right, here we see this is the exact same thing, but with RCX. Vim data.bin. Yup, there we see the random shit. There we see the noise. Okay, now I'm gonna add a NOP in here. inc RCX nop. Oh, that's not, fuck. How do I do an inc RCX and add a byte? How do I do a 4-byte inc RCX? Add RCX1. That's gonna be 2 bytes, I think. That's 4 bytes. Fuck yeah. Add RCX1. So this would have the same alignment properties as add ECX. Otherwise, there's some crazy stuff with 64-bit registers. Look, it's the same. So something about a 3-byte instruction, I bet 3-byte instructions, that means I'm going to execute unaligned instructions. Or like instructions that cross like a cache line, which also would cross an instruction fetch line boundary, which would then cause some... Isn't that fucking wild? Oh my god. Oh, we're learning so much. Holy shit. What the fuck? Dude, that is insane. Data dot. All right. Idea. I'm gonna add a NOP. Maybe try and throw the whole thing off. You know what? It might not have to do with the alignment. It might have to do with the fact that, so we threw a NOP in there, so now they're on a different alignment, which means if they were synced up here, now they would be desynced with respect to 16 and 64-byte boundaries, right? Because we added 1 byte extra. The absolute data in this graph is not going to be accurate anymore because we aren't adding that NOP in. Oh. Okay. I'm going to run that again. And then I'm going to remove that NOP. No fucking way. No way. No way. I guess we don't need the full data set. We're just going to go up to 50. Actually, we'll go to 40 because it will fit on one screen, so I won't have to worry about scrolling. Or I'll do 30 to be even safer. I think 30 was deep enough to see. Actually, 40 will fit on the screen. Okay. This will also increase the frequency of sampling and testing that. Let's see what we get here. Dude, does alignment of the instructions matter? That would maybe make sense. Vim data.bin. Yep, so that's not deterministic. Okay, cool, noted. And then I'm only going to get rid of a NOP. That's it. That's it. That's all I'm gonna do. Gonna get rid of that NOP. I did change a constant from 40, so there's a chance that that constant has changed something in the assembly and we're on a different alignment. What the fuck? I'm gonna take a bio break. I gotta think about this. That is nuts. That's pretty crazy. What the fuck? All right, do you think it's cache line related, or do you think it's cache line related, or like 16-byte instruction fetch line related? We saw it when we were doing 3 bytes. We saw it like every 4 bytes. We saw the jump, which 4 times 3 is very close to 16. So it makes me think that it's that window. So the way I can test that is, first let me align, I'm gonna align 64. This is gonna be 2, jump 2F. So 1 instruction, 2 instruction, 3 instruction. Yeah. 1 retire, 2 retire, 3 retire. So now we need to change this to 3. So we're gonna align, actually, who even cares? We're fucking 4K aligning that. So we're gonna 4K align that. Actually, 64 bytes probably good enough for this case. And let's see what happens when we split different boundaries. So I just want to make sure this is working. This will end up putting all of the add instructions on the 64 byte. They're all aligned here. Data. Oh, we got issues. We got issues. Is the act of jumping going to be a problem? Is jumping to that hurting us? Is that going to be a problem? These are 4 bytes, right? Yeah, these are each 4 bytes. At RCX 1, I'm actually really confused then. The initial jump might be breaking that. Yeah. That is weird. Align 64. And I should be able to see a bunch of knops if I less this. It'll be like a bunch of big knops. Yeah, we got the big boy knops, and then we jump past them. And that should definitely be aligned. Okay, let me try align 8. Or actually align 16 for now. Maybe that branch is throwing a wrench and everything. It's an unconditional branch, but that could... That's a variable we haven't been playing with yet, so maybe doing a branch is not ideal. Let's see what we got here. I think there's going to be noise if there's a branch. Yes. Okay, let's get rid of the branch. Now we don't know how many instructions we're executing, which is the downside, because there might be a different amount of padding. In this case, it's 2 more instructions, but we don't care about the absolute numbers right now. So I'll just ignore that. Let's see what we get. Whoa. What? Okay, we're going back to what we originally had. Whoa. What would that be then? This, I think this one worked. This one had no non-determinism, I think. Yeah, this one's clean. And what's the pattern we're seeing? I need to get the address. I think I need to figure out what address that is at 2. At the very end, I'm gonna do an LEA into 0 of rip plus 2b. We're gonna output this into like equals assigned to a register, and we're gonna call this add sled. Let me add sled. Set that up here. Then down here, print add sled is at x add sled. That's gonna print a couple times, but it's not too big of a deal. Not too worried about it. Add sled, give it a type. Yeah, I can give that a type. U64. Technically, it's assigned to, so it's fine. Okay, so we're gonna pick that up. Rip plus 2b. EED. D. Is it the opposite? Wait. EED. Really? Ah! We have a mismatch. We potentially changed some like register saving and restoring context. So this is running it again, different address, EED again. Okay. What's going on here? Oh, server's lagging. Server DC'd. Okay. So that's at EED, data.bin. Oop. That's the same one, though. I guess we've seen that sometimes it can differ. Okay. EED. Yeah, we're seeing blips every once in a while. That's rare. That's a really rare. Really, really, really rare. And then if I add a nop, I'm gonna add a nop here. See what we get. So this should be at EEE now. Yup. Yee. See what you get here. Why would EED be different? Wow, and there's all of the weirdness. EEE. How? Well, I have no idea what could be causing that. Let's see if I do another knop, if it gets back into shape. I'm gonna do a couple more tries here. It should be a EEF. So these instructions are going to... These instructions are going to be unaligned. Okay. And there we just see it very slightly. It seems like it's modulo the number of knops. Like we're adding one more instruction. Now we're 16-byte aligned. Hey, what's up, Bangpa? How's it going? Let's take a look here. Oops, vim data.bin. Okay, that's looking good. Now sometimes we're seeing blips. All right. Let's try it again. That's so weird. Yeah, that's clean. Okay, and then we'll add one more. Add another knop, and now we're like... We've got some weird alignment going on again. Here we go. Now we're at F1. Okay. So 1 was fine, but so was D. Was it D that was fine? No, D was the one that had weird things, and this would be D. This is the mod for D. This is four knops. Or 1, oh, no, this is 5 knobs. Whoa. Wow! That's so bizarre. I have no idea. I have no idea. Yeah. It seems like it has something to do probably with the instruction alignment. We can verify if it has something to do with the instruction alignment or if it has something to do with the instruction. We can check if it's alignment or the instruction count. So what we're gonna do is we're gonna have we're gonna XOR ECX. This is gonna have and then get rid of a NOP. So this was 5 bytes of NOPs. This is going to have 5 bytes of stuff. But yeah, here we have 5 bytes. 1, 2, 3, 4, 5. But this will have the same alignment, and we'll see if we have the same properties. And if we do, then it's something alignment related rather than instruction count related, which would make a lot more sense. Instruction count wouldn't really be a reasonable thing for these things to diverge on. Whoa. Well, that fixed it. Maybe it is instruction count? Where'd you go to school? I didn't go to school. I just went right into work. Add RCS by 1. I have no idea. I have no idea. I don't even know anymore. All right. We're gonna get rid of that stuff. We're gonna go back to inc our ECX, and we're gonna go up to 1000. We're just gonna collect the data, and then I think I'm gonna call it there for the stream because I do want to sleep. I am quite tired, even though it's early. Oh, ECX, yeah, probably should zero out ECX, you know. Zor ECX. Okay. Oops. I ran it twice. Oh well. Well, I have data. Okay, that's looking good. And then GNU plot p plot perf counter dot plot. Data looks great. Is there... So it syncs up at the end. I wish there was a way for me to pan the graph. I don't think there is. And then down here, there's some desyncs. Okay. And then if I graph perf counter, if I plot the difference from the expected minus actual, whoa, is there some outlier in here? What? What? Oh, yeah. That's because this is the one that I didn't have it zeroed. XOR ECX. There we go. Okay. Then regenerate the data. Whew. There we go. FO, add sled. Add that. Ooh, that one happens to be aligned. Oh, this one doesn't have any non-determinism, does it? It does not. And that's because that's F aligned. Vim data dot bin. No outliers. Okay. So then if we go to inc RCX, which will make that instruction, this is like worst case, super noisy. I'm gonna copy data.bin data aligned inc AX .bin, and we'll regrab this data. Yep. I think coincidentally we just happened to be aligned on our stuff. Like I have no idea how, but we just coincidentally were aligned. Something here has to do with the memory alignment. And maybe the instruction counts. It's really hard to say. Data.bin. This one should have issues. It does. Looks great. Love it. Okay. Yeah, and here we have all the noise. So, actual. Yeah, and that's fine. I'm okay with being in the negatives here. Let's zoom in. Okay. Let's vim plot perf counter set x range. We'll set it to like 5 to 25. Okay. So we've seen it off by 22 to 27. How big is that range? 27 minus 22. The 22 is rare. That's 5. But I think we're going to see a pattern. Let's go to 100 on the X range. We can actually do 2 to 100. And we see 22 to 27 again. I don't think I see any patterns in here. And I don't know if I would. It's interesting. So we've got like up, down, down, up. Whoa. Are we gonna see that pattern? Is that, okay. There might be a pattern here. Let's go to 150. So that's up, down. Yeah, that's zigzagging. That's zigzagging here. And we see a zigzag happen here as well at an earlier phase where it's 1, up, down, down, up, down, down, up. And that's the same pattern that we see here. And I think we see kind of similar patterns leading up to that. Then afterwards, this goes stable. Now we're working with, the instruction count is 3, so since that's a prime, we're not gonna see, we're gonna see, like, the patterns are gonna be very strange here. But I would kind of suspect when the primes line up that we'd see stability. And we see that 1, 2, 3, 4, 5 in a row. Here we see, I guess, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 with spaces, and then it goes to just brrr, dots all the way through. Dude, that is weird. What is this? It is the, like, we're trying to interrupt a program at a very specific point, and this is telling us, based on the location we wanted to interrupt in the application, the noise of the location that we actually ended up getting when we interrupted it. So it basically is, yeah, it's showing that, like, non-determinism. That's so weird. It's so weird. All right. Copy data aligned inc eax to data.bin. And here it is. This is the same data, but when the instructions are aligned. Look at that. Ah! God damn. There's clearly something there. This still has the same range, 23 to 27. So it seems like that is the maximum we can miss by, is 27. 23 to 27. It's actually not too noisy on the miss range there. Let's plot all the data we have from 2 and beyond. Wow, and there's all the dots. And I don't get it. I don't get it. I don't get it. Let's grab this data again. Oh, what was that range? That's what I wanted to see. 23 to 27. Yep. And plot. Oops. Perf counter test. We'll grab this data in again. And we'll see what we get. We're aligned. This is doing the 3-byte ones. This is going to have the noise. But I just want to see what the ranges are in this one. 22 to 27. Oh, someone did a 22. That was early on. That was at, okay. So there's a little bit more noise there. All right, so this looks like a good worst case. So I want to add, I just want to capture data for twice the time. Boom. or 10x the time. So this will take 10x the time to run, but there's going to be a lot more data here. I don't remember how long that took. Probably like 10 seconds, but yeah, I think I'm going to wrap up the stream here. We know that if you undershoot a perf counter for instruction count by like 30, at least in this simple case, you're fine to single step your way to the end. But we still have to look into some edge cases on maybe more complex instructions. So we'll see what that looks like at another date, but I'm going to wrap this stream up short. Thanks everyone for stopping by. It's very strange, but that's the beauty of undefined behavior. So, and thank you for the follow. Hell yeah. Anyways, see y'all around. Thanks for tuning in.